Hey, hi my dear students. Hope you all are doing absolutely good. We are going to do sequence and series in this particular session, and this is the second lecture in our JEE Maths crash course. Coming to the importance of this particular chapter in JEE Mains, we'll be seeing two questions in almost every paper, and it will be very rare if you see one particular question. Okay, and coming to the two questions. Coming to these two questions, majority of the questions have been asked from just simple properties of AP and GP. And second most important segment in this particular sequence and series is sigma related sums, coming to method of difference, or might be sum to n terms and all. So without any delay, we are going to start this particular session. And my dear friends, this is one of the most fundamental topic for every chapter. Like we can see the questions which are based on this particular concept in trigonometry, in everywhere. So rather than seeing this particular topic as a single topic, basic fundamental topic again, this is also. Okay. So friends, chalo. So in today's session, the lecture flow is going to be like, we are going to start with AP, GP, HP, all means we are going to discuss AGP, sigma notations and method of difference. Coming to the first definition, arithmetic progression. Very simple definition, friends. AP is a sequence whose successive terms are obtained by adding a fixed number d to its preceding terms, and this fixed number d is called as common difference. We say is called as common difference. So friends, like if we say a as the first term and d as the common difference, and this is how an AP can be. This is the general form of a AP, general form of an arithmetic progression. AP or arithmetic progression, we say a plus d, a plus 2d, and so on, a plus n minus 1 into d. This is how we define AP. Next, nth term of an AP, nth term, or we say general term of an AP. Suppose friends, like we need to get an nth term. See, first term a, this is first term. Second term, if d is the common difference, we have added d to a, so we get a plus d. And third term, we have added d to the a2, so a plus 2d. Just do understand the relation between the subscript and the coefficient of d. Here if it is 2, it is 1. Here if it is 3, if it is the coefficient of d is 2. So whatever the subscript we have, like nth term, which term we have, the coefficient is just 1 less than that particular thing. So in this particular sequence, if you take nth term of an arithmetic progression, where a is first term and d is common difference, is given by an is equals to a plus n minus 1 into d. A plus n minus 1 into. This is what general term or nth term of an AP we say. General term or nth term of an AP. Next, sum to n terms. In general, suppose if we denote sum of n terms of an AP, sum of n terms of an AP means sum of all the terms like A1 plus A2 plus A3 plus A4 and so on. We have AN. Yeah, so Sn will be equals to A1 is nothing but A, A2 is nothing but A plus D, and A3 is nothing but A plus 2D, and so on, and so on. N minus 1th term will be A plus n minus 2 times D, and nth term will be A plus n minus 1 into D. Clear? Now, what I'm trying to do is, like, I'm just going to reverse the sequence. Like, I'm just going to write all the terms from that particular end. So, A plus n minus 1 into D plus A plus n minus 2 times D, and so on. Second last term, A plus D, and last term will be A. Now we are going to add this particular sequence. See friends, Sn plus Sn will be 2Sn is equals to A plus n minus 1 into D. We get 2A plus n minus 1 into D. In the same way, if you are going to add any, like these two consecutive, like these two corresponding terms, 2A plus n minus 1 into D in the same way. Adding these two corresponding terms, we will be getting 2a plus n minus 1 into d, and so on, 2a plus n minus 1 into d. Each corresponding each of these two corresponding terms, if we are going to add, we'll be getting 2a plus n minus 1 into d. So 2 times Sn is equals to 2a plus n minus 1 into d is being added itself n number of times. So we can just write it as n times 2a plus n minus 1 into d. Here, hence we can write Sn is equals to n by 2 times 2a plus n minus 1 into d. So this is how we find the sum of first n terms of an AP, friends, where a is the first term and d is the common difference. Even we can write even this as like Sn is equals to n by 2 times 2a can be written as a plus a, and as usual a plus n minus 1 into d we have. So if you just observe this particular thing, n by 2 times a plus n minus 1 into d is nothing but an we have. So this is like, we can say even like n by 2 times a plus l, where l is the last term or nth term we can say. The same sum to n terms can even be written as n by 2 times a plus l. And one most important relation that we can frame here is, just do understand, friends, we have this a plus n minus 1 into d na. Nth term of an AP, if it is equals to a plus n minus 1 into d, see this can be like, if you're going to form a linear equation in terms of d, in terms of n. Now an is equals to nd plus a minus d. So if an is equals to some capital an plus b, every general term of an AP, will be of the form linear expression in n, and one important thing that you're supposed to understand is, you just compare these two equations. Here what is the coefficient of n? Capital A. What is the coefficient of n here? Capital D. So if a general term of an AP is expressed in linear expression, is expressed as linear expression in n, then the coefficient of n is nothing but the common difference. The coefficient of n is nothing but the common difference, and the constant is going to be the difference of first term and common difference. The first term and common difference. Very important, very important. Kindly make a note of it. In the same way, if you are going to take this particular thing, now we have Sn is equals to n by 2 times 2a plus n minus 1 into d. Just multiply, we get Sn is equals to n by 2 times 2a, we get na plus n by 2 times n minus 1 into d. Then that becomes Sn is equals to na plus n by 2, n square by 2 times d minus n by 2. That becomes Sn is equals to n square by 2, n square into d by 2, n square into d by 2 plus n common, then we get n common, then we get, or n by 2 common, to n by 2 common, 2a minus d we get, 2a minus d we get. Clear? Now if we are going to express this particular thing as like a quadratic equation in terms of an square plus some bn, an square plus some bn, see friends, very simple, very simple. And the thing is, the coefficient of n square, just compare these two equations. The coefficient of n square is going to be half the common difference, that is a is equals to d by 2, and the common difference is going to be d is equals to 2a. We are going to have some good sums based on this particular concept too. So every sum to n terms of an AP can be expressed as a quadratic equation in n, that is in the form an square plus bn, and the coefficient of n square is a is equals to d by 2, and the common difference, if it is expressed in this particular form, the common difference is going to be d is equals to 2a. Clear, friends? Next, note, that is what we have just discussed. Nth term of an AP is of the form, always of the form an plus b, that is the linear expression in n. In such base, the coefficient of n is, in such case, the coefficient of n is going to be common difference of the AP, that is a. Just now we have seen. And even sum of n terms of an AP can be expressed as the quadratic in n of the form an square plus bn, and the coefficient of n square nothing but 2a is going to be our common difference. Clear? Also, like Tn, another important statement that we have, Tn is equals to Sn minus 1. See, the thing is very simple. See, what is Sn, friends? It's like sum of all n terms, sum of first n terms. So T1 plus T2 plus T3 and so on, Tn minus 1 plus Tn. Now if I just write Sn minus 1, this is nothing but sum of first n minus 1 terms we get. Sum of first n minus 1 terms. So that is nothing but T1 plus T2 plus T3 and so on plus Tn minus 1. Now if you are going to just subtract these two equations, then what are we going to get? Yeah, Sn minus Sn minus 1 is equals to T1 minus T2, T3 and so on, everything gets cancelled, you will be getting Tn. So from here we can just write Tn is equals to Sn minus Sn minus 1. Guys, I hope it is clear. Yes, good, awesome. Yes, now once we discuss a particular progression, we'll in sequence we'll be going with its properties. See, my dear friends, properties of AP GP are very important, because try to understand these properties, at the same time try to analyze them. So unless and until you analyze, you won't be getting a good grip on it. Okay, coming to the properties of AP, the first property, the first term and common difference can be 0, positive or negative or any complex number. Clear? If ABC are in AP, 2B is equals to A plus C. That is nothing but, friends, like C. If A comma B comma C are in AP, we say, then the common difference is going to be same, na? What is going to be the common difference? Second term minus first term will be equals to third term minus second term. So that becomes B plus B is equals to A plus C. So finally 2B is equals to A plus C we get. So if A comma B comma C are in AP, then we say twice the middle term is equals to sum of the extremes. Sum of the extremes. Then third property, selection of terms. Like in problems we coming across like 3 terms of an AP. The sum of the 3 terms of an AP is going to be that, is going to be this or that. Sum of 4 terms of an AP. Selection of terms plays a very important role. In that case, if you are going to just select a normal general form of AP like A plus D, A plus 2D, we will be like the calculation is going to be very hard, hectic. In that case, selection of terms plays a very simple role in simplifying all our calculations, because like if you are going to take like they are asking 3 terms of an AP. Okay, now if you are going to follow this particular pattern, what happens is they give you like sum of the terms is going to be so and so. In that case, see, if you are going to add A minus D, A plus D, directly D will be eliminated. You have got the A and there will be only one unknown D now. Okay, so that is the importance of it. Please make sure that the selection of terms, whenever they ask you like 3 terms, 4, in general we come across like majority 95% of the cases we go with like selection of 3 terms only. Rare 4 terms, but these two not necessary to, like selection of 3 terms, A minus D, A plus D. Selection 4 numbers, 4 terms in AP, A minus 3D, A minus D, A plus D and A plus 3D. The purpose of selecting these is like if you are going to add them, D is going to be eliminated. We will be getting A. Okay. One most important thing is, in this case the common difference is going to be D, but in this case the common difference is going to be 2D. Okay. So once you get like everything A, D and all, at last the final common difference of that particular sequence is going to be 2D. Clear? 2D. Good. Sum of the terms equidistant from beginning and end are always equal. Yeah, I mean like, see friends, I take a general form of an AP. A general term of an AP. A plus D, A plus D, A plus 2D, A plus 3D and so on, A plus n minus 3 times D, A plus n minus 2 times D, and A plus n minus 1 time D. n terms of an AP, n terms of a finite AP we have. Just do understand. The sum of the terms equidistant from beginning and end are always equal. Suppose if I say first term from first and first term from the last, if you are going to sum these two, what happens? And anyhow, we have seen the same in proving this particular sum of n terms of an AP. See, this is what we did here. First term from the first and first term from the last. Sum is going to be 2a plus n minus 1 into d. Second term from first and second term from last is going to be same. So in that way, the sum of the terms which are equidistant from beginning and end are always found to be equal, or always found to be equal, or always found to be equal. I hope it is clear. Next. If each term of an AP is increased or decreased or multiplied or divided by the same non-zero number, then the resultant sequence is also will be in AP. Very, very simple. We can just go with like small example, friends. See, let me take 2, 4, 6, 8, 10, 12. This is a finite sequence of in AP of 6 terms. Now just do understand. If I am going to add 3 to each and every term, see 3 plus 2, 5, 3, 4 plus 3, 7, 6 plus 3, 9, 8 plus 3, 11, 10 plus 3, 13, 12 plus 3, 15. Even this sequence is also in AP. In the same way, if you are going to subtract, see these properties are very important in solving problems for JEE. Okay. If you are going to subtract a non-zero, a fixed constant to each and every term, the resultant sequence will also be in AP. If you are going to multiply a non-zero number with each and every term, yes, the resultant sequence will also be in AP, same division too. So either multiplication or division or addition or subtracting a non-zero fixed constant to each and every term of an AP, the resultant sequence will also be in AP. The resultant sequence will also be in AP. Next, this is one more very important. Nth term, kth term from last is equals to n minus k plus 1th term from the beginning. Sometimes in sums they will be giving you the 13th term from the end. The 13th term from the end is so and so. Friends, if I say like first term, like 10th term, I mean by default it takes from the left to right itself, from starting to in that particular way. So 13th term from last or 14th term from last, that means like kth term from the last is nothing but kth term from the last is nothing but n minus k plus 1th term from the beginning, that is ak is equals to, I mean not ak means kth term. So kth term from last will be equals to a of n minus k plus 1th term, a of n minus k plus 1th term from beginning. If I am saying a particular term, it has to be from beginning itself. Okay, clear. Next, any term of an AP except the first is equal to half the sum of the terms which are equidistant from it. An is equals to, so this is what again very important property, friends, very, very important. Like the C, I mean like here we are going to be a plus 3d. Next a plus 4d and so on. Just do imagine. Now if I consider a particular term, okay, for this term, this is to the left of one, this is to the right of one particular term. If you are going to add these two, a plus d plus a plus 3d, and make it half, you will be getting it. And this is what that particular sequence is. And for this particular term, if you are going to take two terms, a plus 5d you take, a plus d plus a plus 5d, that is nothing but 2a plus 6d, half of that you will be getting a plus 3d. So that is what we say, any term of an AP except the first has to be excluded, is equal to half the sum of terms which are equidistant from it. That is an is equals to, we say an is equals to any term half of a of n minus k. That means k units to the, you are going to the left, and k units to the, you are going to the right. N minus k plus a of a n plus kth term, where k should be less than n. Where k should be less than n. And these are the simple properties of FE, friends. Next, another we are going with the next sequence, that is geometric sequence. So geometric progression, simply we denote it as GP. It is like same like AP. There we are going to add a fixed constant. We are going to add a fixed constant to its preceding terms. Here we are going to multiply a fixed constant to its preceding terms. That's it. Apart from that, everything is simple. That fixed constant is called as common ratio, and it is obtained by dividing any term by that which immediately precedes it. Suppose if I say A1, A2, A3 and so on, AN forms a GP, I mean to say, friends, common ratio R is equals to a term divided by its preceding term, A2 by A1, or even we say A3 by A2, or even we say AN by AN minus 1 in general term of a GP. See friends, like first term, if I say first term A and a common ratio R, if you are going to multiply that R to this, you will be getting the second term. So A1 equals to A. A2, we are going to multiply R to this preceding term, we get AR. So A3, AR into R, we get AR square. Just understand the relationship between the subscript and the power of R, the exponent of R. See, it is 1 less than this. So A4 will be A into R to the power 3. In that way, we get AN, nth term of an AP or a general term of an AP. AN is equals to A into R to the power n minus 1. A into R to the power n minus 1. A into R to the power n minus 1. This is going to be the general term. And general form of a GP is going to be like very simple. AR square, AR cube and so on. Nth term will be A into R to the power n minus 1. A into R to the power n minus 1. Clear? And sum of first n terms of a GP, see friends, like sum is nothing but sum of all the terms like A1 plus A2 plus A3 and so on plus AN. That is nothing but Sn is equals to A, A2 is AR plus AR square plus AR cube and so on. A into R to the power n minus 2 plus A into R to the power n minus 1. Just do one thing, friends, do one thing. The proof is going to be very simple. Identify the common ratio R and multiply it both sides of the equals to. So R into Sn, you get like R into Sn is equals to, you're just changing the pattern of terms, like corresponding terms, like A into R, you get AR na, you just write here. Yeah, this will be easy for subtraction. AR square plus AR cube and so on plus A into R to the power n minus 2 plus A into R to the power n minus 1 plus R into A into R power n. You get the last term will be A into R power n. Now friends, do subtraction. Subtract these two equations. So Sn of 1 minus R is going to be AR square, everything is going to get cancelled except this first and that particular last. So that becomes A minus A into R to the power n. So Sn is going to be A common 1 minus R power n by 1 minus R. Even we can write this as A into R to the power n minus 1 by R minus 1. R shouldn't be 1 and R can be greater than 1 or less than 1. So this is what this particular sequence. Sum to n terms, very simple friends. A into R raised to the power n by R raised to the power n minus 1 by R minus 1. This is how we are going to find the sum of n terms of a finite GP. Coming to infinite GP, very simple and very, like we have seen this friends. Sn is equals to A into 1 minus R power n by 1 minus R. Just now we have proved it and R not equals to 1. See guys, do understand one thing, like infinite GP means a sequence like it keeps on continuing. It is not a finite GP. Infinite number of terms we are going to have. For that particular sequence, we are going to consider the R value. If R value of an infinite GP is going to lie in between minus 1 to plus 1. If R lie in between minus 1 to plus 1 only, we are going to solve its sum. We are going to find its series. We are going to find the sum of its series. If something, imagine if R either greater than 1 or less than 1, less than minus 1, then what happens? Friends, if R will is greater than 1, its sum approaches to infinity. If R, like according to that it happens. So if R lie in between minus 1 to plus 1, what happens you see friends? Like as n tends to infinity, we have R power n. and the value of r lie in between -1 to +1. Like r can be any value from -1 to +1. So just do understand, any value you take for r which lie in between -1 to +1. Just imagine, like if I take 0.1 power 1, 0.1 power 2, 0.01, 0.1 power 3, 0.001. So as you just do understand one thing, when I keep on increasing the exponent, the values for n, r power n approaches to 0. R power n is approaching 0. So as n tends to infinity, r power n tends to 0. That means for us, s infinity is equals to a of 1 minus 0 by 1 minus r. That becomes a by 1 minus r. So this is what the very simple, friends, very simple sum of infinite GP, and r shouldn't be 0, because if r is 0, the sequence is going to be only 0, 0, 0, 0, 0. Clear? This is what this particular thing, friends. This is what this particular thing, sum of infinite GP. Next, we will be discussing the properties of GP as usual, like we had discussed in properties of AP. Very important. If ABC are in GP, then we say B square is equals to AC. That is ABC. Common ratio is going to be same, na? Like B by A is equals to C by B. Cross multiplication. B square is equals to AC. Okay, that's it. Next, 3 consecutive terms of a GP are A by R, A, AR. Selection of 3 terms in GP. Selection of 3 terms in GP. 4 consecutive terms, A by R cube, A by R, AR, AR cube. That's it. See, friends, like here in this case, common ratio is going to be R. Whereas in this particular case, the common ratio is going to be R square. So just act accordingly. Next, if each term of a GP be multiplied or divided by the same non-zero constant, then the resultant sequence will also is going to be in AP. If each term of a GP raised to the same power, then resultant sequence is also going to be in AP. Properties, very important. Next, in a GP, the product of 2 terms which are equidistant from first and last is always going to be constant and is equal to the product of the first and last term. See, that is very simple, like AR square, AR cube, AR power 4 and so on, AR power n minus 3, AR power n minus 2, AR power n minus 1. See, friends, just do imagine. If you are going to multiply these two, what you are going to get? A square into r power n minus 1. Multiply these two, a square into r power n minus 1. Multiply these two, a square into r power n minus 1. So that is what I mean to say. The product of terms which are equidistant from first and last is always going to be same, and that is equal to the product of first and last term. In a GP, TR square is equals to TR minus K, like we had in AP. See, friends, like suppose if you are going to select this particular term, to the left one particular term, to the equidistant terms, the product of the terms which are equidistant from a particular term is going to be like square root of that, or else like this square is equals to product of these two. See, the product of these two is going to be A into R cube whole square. In that way, another important property. So in a GP, TR square is equals to TR minus K into TR plus K. K units to the left and K units to the right we have selected. If the terms of a given GP are chosen at regular intervals, even they themselves form another GP. I mean, like AR square, AR cube, AR power 4, AR power 5, AR power 6 and so on. See, friends, like if you are choosing terms at regular intervals, that means like AR I have chosen 2 units, then AR power 4, 2 units, A into R power 7. Just do understand, AR power 4, AR power 7, these terms will be again in GP. So terms chosen at regular intervals, even they will also be forming a new GP. If A1, A2 and so on, like this is very important, friends, 8th property. For a terms in GP, if you are going to apply logarithm to each and every term, then the resultant sequence is going to be in AP and vice versa too. If A1 to AN in GP, then all these must be positive because logarithm has only positive domain. So positive terms, then log A1, log A2 and so on, log AN is an AP and vice versa. Next, if A1, A2, AN and so on are 2 consecutive, like 2 corresponding GPs, then the product of the corresponding terms, and if you are going to divide the corresponding terms, even these also forms a GP. These also forms a GP. So these are the properties regarding GP, friends. Now let's go with harmonic progression, also called as just HP. It's very simple. Like there are no much things to discuss about HP, but just one simple thing. See, friends, a sequence is said to be in HP. A sequence is said to be in HP if the reciprocals of its terms are in AP. That's it. A sequence is said to be in HP if the reciprocals of those terms are going to be in AP. That means if I say A1 to AN are in HP, that means their reciprocals will be in AP. Their reciprocals will be in AP. So see, very simple, like 2, 4, 6, 8 are in AP na. Then I say 1 by 2, 1 by 4, 1 by 6, 1 by 8 are going to be in HP. There are no specific nth term of HP is going to be like reciprocal of nth term of AP. No sum to n terms in HP. Everything it takes only will be going with complete AP. Next, no term of any HP can be 0, because if a term of HP is 0, then reciprocals we take 0, 1 by something 0 na, then that's going to be again that should be in AP, but some not defined, a term which is not defined cannot be included in AP. So no term of any AP can be 0. If ABC are in HP, then B is equals to 2AC by A plus C. See, friends, are very simple. ABC are in HP. The moment you see any sequence in HP, the first and important thing that you're supposed to do is take the reciprocals. Their reciprocals will be in AP. So that means 1 by A, 1 by B, 1 by C will be in AP. In AP we know na, twice the middle term is equal to sum of the extremes, that is 1 by A plus 1 by C. So this is nothing but twice the middle term, 1 by A plus 1 by C. So that becomes 2 by B will be equals to A plus C by AC. So B by 2 is equals to AC by A plus C. From there finally we get B is equals to 2AC by A plus C. 2AC by A plus C. This is going to be thing. Very, very, very simple. Very easy. That's it. We can even prove the same here like this also. Okay. Oh, I hope you understood, guys. Only one part. If ABC are in HP, then we say B is equals to 2AC by A plus C. Even we say B is harmonic mean. Next, we'll go with like PYQs. So these are the basic things that we have discussed, like AP, we have discussed HP, AP, GP, HP and their properties too. Now, based on these simple things, how the questions are being asked in different JEE years. See, friends, for any three positive real numbers, A comma B comma C, 9 times 25 A square plus B square, 25 times C square minus 3AC is equals to 15B times 3A plus C. Then what are these they are asking? Just do understand, friends. Just very simple this. Multiply 9 into 25. 9 into 25 is going to be 15A square. Sorry, 9 into 25. 225A square plus 9B square plus 25C square minus 25 3 75AC is equals to 15 3s are 45, 15 3s are 45AB plus 15BC. 15BC. This is the thing that they have given. Now just see. This can be written as 225A square can be written as 15A whole square plus 3B whole square plus 25C means 5C whole square minus this 75AC can be written as minus 75AC can be written as 15A into 5C. Get everything to this side minus 45AB can be written as 15A into 3B minus 15BC can be written as minus 3B times 5C is equals to 0. Friends, very basic formula that we have. A square plus B square plus C square minus AB minus BC minus CA is equals to 0. If A square plus B square plus C square, that we have already discussed in our first lecture, that is basic mathematics. A square plus B square plus C square minus AB minus BC minus CA is equals to 0. Then A equals to B equals to C. What can we do? Like we can just multiply and divide with 2. Then we get of the form m of A minus B whole square plus B minus C whole square plus C minus C whole square is equals to 0. So A equals to B equals to C. That means here, what is A, what is B, what is C we have? That is 15A is equals to 3B is equals to 5C. Let me take all these equals to some particular lambda. Okay. Since just to avoid the calculations, I just take 15 lambda. You know why did I take 15? Because the LCM is going to be 15. I don't want everything to be in fractions. Like, so I want in simple terms. Like, so what will be A now? A will be lambda. What will be B? B will be 5 lambda. What will be C? What will be C? C will be 3 lambda. C will be 3 lambda. See friends, very simple now. 5 lambda, 3 lambda, comma lambda, that is B, C, A. See, the common difference is going to be 2. So B, C, A are going to be in AP. Such things are very simple. This was asked in the year 2017. Very basic thing, na? Very basic thing. Just we have converted everything in terms of standard form. Then it found to be in a particular algebraic identity. By using that, we have just simplified. And by using the properties of AP, we just said BCA are in AP. BCA are in AP. Next, second question. This was asked in the year 2016. Friends, A1 to AN are in AP. A3 plus A7 plus A11 plus A15 is equals to 72. Then the sum of its first S17 they are asking. S17. Basic thing. Again, basic thing. Basic thing. We can just go in a normal procedure like A3, or we can even like sum of the terms equidistant from beginning and end will be equal. Like suppose if you are going to take 17 terms, the same, like see, okay, we'll be going in general method. A3 is nothing but A plus 2D, A7 A plus 6D, A11 A plus 10D, A15 A plus 14D is equals to 72. 4 A's plus 2 plus 6, 8, 8 plus 10, 18, 12, 22. 2 plus 6, 8, 8 plus 10, 18, 18 plus 4, 22, 32D is equals to 72, friends. Just take 4 common. So 4 of A plus 8D is going to be 72. So that becomes 4 1s ja, 4 1s 4, 4 8s ja 32. So we get A plus 8D is equals to 18. Now we just keep this aside. Now they are asking us to get sum of first 17 terms. Yes, 17 they are asking. What is S17 in general? N by 2 times 2A plus 16D. 2A plus 16D. So 17 by 2 times, we can just take, so A plus 8D we get. 2 gets cancelled. 17 times 18. That's it. 7 8s are 56. We get 306. Hope it is clear, friends. 17 into 18. 3. So very simple, na? Just it won't even take like 30 seconds even. So that much easy it is. Like if ABC, another question which was asked in the year 2019. ABC be 3 distinct real numbers in GP and A plus B plus C is equals to XB. Then X cannot be, they are asking. X cannot be. 3 distinct real numbers in GP. A plus B plus C. See friends, like let me, like general form of a GP. R is the common ratio. Then B will be AR. AR square. A, B, C are in GP. So this is like A is A. This is B, this is C. Let R be the common ratio. Then B equals to AR, C equals to AR square. Just substitute in the given equation. A plus AR plus AR square is equals to XB, X into AR. A can be cancelled. So just I can write this as 1 plus R square is equals to XR. See friends, we are just able to get a quadratic in terms of r. So that becomes r square plus r times 1 minus x plus 1 is equals to 0. This is a quadratic in terms of r. Okay, this is a quadratic in terms of r. And one important thing is, if you just the ABC be three distinct real numbers, means r is going to be real number. R is going to be real number. If r is going to be a real number, then the discriminant of this particular quadratic equation is will be always greater than or equals to 0. That means d greater than or equals to 0. Then we get b square minus 4ac 1 minus x whole square greater than or equals to 4 times ac. That's it. So that becomes, see, very simple. Like we can just go with like 1 minus 4 3 square 9, 1 plus 3 minus 2. Yeah, yes, if you're going to take x2, see 1 minus 2 whole square, 1 minus 2 is minus 1 whole square, that is 1 greater than or equals to 4. Yes, it falls for only x equals to 2. So x cannot be 2. Hope you understood, guys. See, this was asked in the year JEE 2019. How the simple, like always make sure that our approach, the proper approach is going to lead our proper destiny. Another question which was asked in the year same 2019, ABCB 7th, 11th, 13th terms respectively of a non-constant AP, if these are also the three consecutive terms of a GP, then A by C is equals to. Friends, will you be doing it? I'll just give you a small simple thing to just crack it, okay? A7, like see, what is A7? In general, ABC, A is like A7 is equals to A. Next, 11th term, A11 is equals to B. Next, 13th term, A13 is equals to C. Let me take capital A as the first term and capital D as the common difference of that particular AP. So what happens now? This becomes A plus 6D, okay? This becomes capital A plus 10D. This becomes capital A plus 12D. But they said these three are also the three consecutive terms of a GP. Let me take R as the common ratio of that particular GP. Okay. So that becomes, let this be A, R be the common ratio. So AR and AR square. Clear? Guys, 7th, 11th, 13th terms of a AP respectively, and all these three are also the three consecutive terms of a GP. And that is what AR square. Okay, clear? Now just very simple, friends. If you are going to take this as like three equations, first we'll go with equation 2 minus equation 1. What we get then? A plus 10D minus A plus 6D. Then you get 10D minus 6D. 4D will be equals to A of R minus 1. In the same way, third equation minus first equation we do. Then we get 12D minus 6D. 6D is going to be equals to A of R square minus 1. Now divide these two equations, friends. 4D divided by 6D is equals to A of R minus 1 divided by A of R square minus 1 can be written as R minus 1 into R plus 1. A gets cancelled, R minus 1 gets cancelled, 2s are 3s are. So 2 by 3 is equals to 1 by R plus 1. Just cross multiplication. Then we get 2R plus 2. 2R plus 2 is equals to 3. So 2R is equals to minus 1. R is going to be minus 1 by 2. Okay. Now consider, then A by C is equals to, very simple. Once you get R equals to minus 1 by 2, see, just substitute here, you will be getting A by C. A by C is nothing but A by C, what is C, friends? AR square, na? AR square. A gets cancelled, 1 by R square. That is nothing but 1 by R square is 1 by 4, which is equals to 4. Friends, I hope it's making sense. See, the concepts, the method that we are approach is quite simple, and it is only just by using the simple properties of AP, GP, HP. And even just not even properties, only the definitions we have taken. Clear? So sum of an infinite GP with positive terms is 3, and the sum of its cubes is going to be 27 by 19. Then the common ratio of this particular sequence is. Friends, I'll just assign you as homework, but I'll just tell you. See, this question was also asked in the year 2019. Friends, like the sum of an infinite GP, sum of an infinite GP. Let A be the first term and R be the common ratio of an infinite GP. Then what will be sum of an infinite GP? A by 1 minus R is going to be is 3. Next, the sum of the cubes of its terms means if each cube, like each term is going to be like A cube, next something, then AR, A square, A cube, R cube, each cube. Then here in this particular case, what happens? Sum of the cubes, will also be an infinite GP. This will also be an infinite GP even, and A by 1 minus R. Here A becomes A cube and R will be 1 minus R cube is equals to 27 by 19 they have given. See friends, like if you are going to cube this particular equation, now A cube we are going to get 27 times 1 minus R whole cube. Here A cube is equals to 27 by 19 times 1 minus R cube. Factorize this, A cube minus B cube, and by just dividing these two equations, you will be getting the solution, the required thing, the common ratio. R, they're just asking us to find the value of R. Hope you'll complete it. Will you? Good. So I'm just assigning you this as homework, friends. That's it. Moving to the next one. If 19th term of a non-zero AP is 0, then it's 49th term. Very simple it is. Like 19th term of a non-zero AP is 0. That means like A19 is equals to 0, which implies A plus 18D is equals to 0. Okay. Then the ratio of, then the ratio of 49th to its 28th term they are asking. Acha. So see, A is equals to minus 18D. From here we got a relation. In terms of A and D. Now we'll be substituting A49 divided by A29. What is A49, friends? A plus 48D whole divided by A plus 28D. But A is already minus 18D, no? Minus 18D plus 48D. See, very simple. This was asked in JEE. Minus 18D plus 28D. We get 20D divided by minus 18. Like this. Sorry. 30D. 30D divided by 10D. Answer is going to be 3:1. See, what did we use any particular thing here? We have just used the definition of AP here. That's it. Clear, friends? Good. We'll be moving to the next. The product of 3 consecutive terms of a GP is 512. If 4 is added to, again, like see in the year 2019, how the pattern of questions are being asked. Just do understand the approach, friends. Do understand the approach. The product of 3 consecutive terms of a GP is 512. If 4 is the product of 3 consecutive terms of a GP is going to be like, see, product of 3, whenever selection of terms comes into action here, let the terms be A by R, A, AR. Clear? Let the terms be A by R, A, AR. Now he has given that the product of these 3 terms, that is A by R into A into AR is equals to 512. So RR gets cancelled. A cube is equals to 88, 64, 68, 32. So 512 can be written as 8 cube. That becomes A equals to 8. See friends, by using this particular selection of terms, we have directly got the value of A. Clear? Now as we got A equals to 8, next what happens? See, if 4 is added to each of the first and second, 4 is added to each of the first, that is, now the terms are 8 by R, 8 and 8R. We have added 4, like see, 8 by R plus 4, then 8 plus 4, 12, next 8R, that's it. For third term, nothing is being added. 4 is added to each of the first and second of these. The three terms now form an AP. Now form an AP. The sum of the original three terms. That means they are asking us to get the sum of these three terms. First, now these three are in AP. Boss, if these three are in AP, what happens? What happens? 2b will be equals to a plus c. 2b, that is 2, 12 2s are 24 is equals to a plus c. 8 by r plus 8r plus 4. Clear? So 20 is equals to 8 by r plus 8r. 4 5s 2s. So 5 is equals to 2 by r plus 2r. 5 is equals to 2 plus 2r square plus 5r. So 2r square minus 5r plus 2 is equals to 0. So 2r like can be factorized as 2r minus 1 into r minus 2 is going to be equals to 0. Friends, r equals to 2 and r equals to 1 by 2 you got. But see friends, the product the three terms now, the sum of the original three terms. Yes, now we got r, we got 2. We can just take even r equals to 2 or r equals to 1 by 2. That this won't affect our result, because either you take r or r 1 by 2, you are going to get the same numbers. See, 8 by r, like 8 by 2, 4, 8 2s are 16. Either if you are going to take 1 by 2, 8 by 1 by 2, 16, then 8, then 4 you get. So the three numbers are going to be 4, 8, 16, and the sum is going to be 28. 16 plus 4, 20, 20 plus 8, 28. So this is how, see friends, like how the pattern of questions are being asked. Very basic properties. So one particular question from basic properties will be guaranteed, friends. Make sure that you are thorough with all the properties and definitions of AP, GP, HP. Clear? Next, this is just by using our simple property called, like just in the beginning we have seen some of the terms can be expressed as a quadratic expression. Sn is equals to an square plus bn, and the coefficient of n square is a, and that a is nothing but half the common difference. Clear? Now just see this friends. Sum of first n terms, see they have given Sn is equals to 50n plus n into n minus 7 whole divided by 2 times a. Is this clear? Is this clear? Now Sn is going to be very simple, friends. I can assign you this as homework, but just 50 times n plus n of n minus 1 by 2. Even then the ordered pair of d comma a 50 they are asking. Very simple. Just do understand. N of n minus 7. So then you get a by 2 times n square minus 7n. Here Sn will be equals to 50n plus a by 2 times n square minus a by 2 times 7n. This becomes Sn is equals to a by 2 times n square, yes, plus n common, n of 50 minus 7a by 2. 50 minus 7a by 2. Directly the coefficient of n square is going to be half the common difference. That means d by 2 is equals to a by 2. We get d is equals to capital A. And even in the same way we are going to relate the coefficient of n. There we got whatever we got here. So in that way you just equate it and get this particular result, my dear friends. Hope you will complete this particular remaining portion. Okay, very simple. From just basic like sum to n terms of an AP, an square plus bn. There the coefficient of n is b. Here the coefficient of n is 50 minus 7a by 2. Equate this to that particular b and get first term. Then they are asking like a 50 a plus 14 d you get. Clear? Very simple, friends. Very. Hope you will complete it. Hope you will complete it. Make sure you are completing it. Next, Sn denote the sum of first n terms of an AP. S4 16, S6 48, S10. See, basic question they have asked in the year 2019. This was a very basic question, friends. Very basic question. Like such problems we have even discussed in CBSE grade 10 too. In CBSE grade 10, this pattern of questions are being asked. See how it is going to be simple. S4, like S4 is going to be n by 2. 4 by 2 times 2a plus 3d. This is going to be 16. Next, S6, 6 by 2 times 2a plus 5d is equals to minus 48. 2 1s are 2 8s are 3 1s are 3 16s are. See friends, 2a plus 3d is equals to 8 and 2a plus 5d is equals to minus 16. We can just by using elimination method or use any method get the value. Two equations, two unknowns we got. We have to get the value of a as well as d. Of the moment you get, they are asking us to get S10, that is 10 by 2, 5 times a plus 9d, 5 times 2a plus 9d. Substituting it, you will be getting it. Clear? Is that clear, friends? See, I'll just complete, I'll assign you this as homework. Please make sure you are completing it. You are completing it. Coming to the next question, this question was asked in the year JEE 2020. Coming to this, the number of terms common to these two APs, they have given two particular APs, two distinct APs they have given. Now they are asking us to get like number of terms in these two sequences. See friends, this is again very simple one. Like if you go with the first AP, first sequence that you have observed, 3, 7, 11, 3, 7, 11, common difference is 4. So 15, 15 plus 4, 19, 19 plus 4, 23. 23 plus 4, 27 and so on till 407. Second AP, if you see 1, 2, then 2, 9, 2, 9, 16, 7 is observed to be the common difference. So 2 plus 9, 7, 2 plus 7, 9, 9 plus 7, 16, 16 plus 7, 23, 23 plus 7, 30 and so on till 709. One thing friends, the LCM of like coming to the common number of common terms, the first common terms is observed to be 23 and the LCM of this like the common difference of the new resultant sequence is going to be the LCM of the common difference of these two. 7, 4, 28 is going to be the common difference of this particular sequence. So first term is 23, 28. So 28 plus 23 is going to be 51 and so on. This nth term of this sequence should be less than or equals to 407 friends. The nth term should be less than or equals to 407. What is nth term? So a plus n minus 1 into 28 is less than or equals to 407. So this, if you are going to solve, you will be getting n is less than or equals to 14. That means n value is going to be 14. So the number of terms common of these two APs is going to be n equals to 14. There are 14 terms common. This is a good one, but just simple one. Next, given an AP whose terms are all positive integers, the sum of first 9 terms is greater than 200. Sum of first 9 terms is greater than 200, okay, and less than 220, okay. Very like positive, all positive integers they have given. Just see friends, like 200 less than S9 is nothing but 9 by 2 into 2a plus 8d less than 220. So 200 times 9 times a plus 4d, 9 times a plus 4d less than 220. 200 divided by 9, given an AP whose terms are all positive integers, the sum of first 9 terms is greater than 200 and less than 220. If the second term in it is 12, then its fourth term is going to be, okay, let's see this, 200 by 9 less than a plus 4d less than 220. Second term is going to be 12. So second term is nothing but a plus d is going to be how much, friends? 12. From here a is going to be 12 minus d. You can find even d or anything is fine. Like 209 1 ja 9 2s 18. Yes, are we going in a proper way? Yes, 9 less than 220. Sum of first 9 terms. Yes, so 9 2s 18, again 2 9 22 point something, 22 point something divided by 9 again here. 2s are 9 2s 18 again, we get 4, 9 4s 36, 24 point something. So just take 24, no issues. So 22 point something is less than or equals to, what is a? A is anyhow 12 minus d. So 12 minus d. So 12 plus 3d is going to be 24 point something. Subtract 12, friends. 22 minus 12. It's going to be 22 minus 12 is going to be 10 point something. 10 point something less than 3d less than 12, 24 minus 12, it's going to be 12 point something. Now divide by 3, then you get 10 by 3, nothing but 3 point something less than d less than 4 point something. See, the most important part in this particular problem is given an AP whose terms are all positive integers. That means d should be an integer. D should be an integer. Can you tell me an integer which lie in between 3 point something to 4 point something? Yes, exactly. D will be equals to 4, friends. See, friends, in this question they have not they didn't give you any direct hint. By using this particular inequality relation, we got now d equals to 4. From there we can get a equals to, a equals to, we get now 12 minus 4, 8. So a we got, d we got, fourth term, a plus 3d. That's it. So this is how this was asked in the year 2014 mains. Next question. Sum of first 20 terms of this particular sequence. You might have seen this some majority of these questions. Very simple model they are. Just take S20 is equals to 0.7 plus 0.77 plus 0.777 and so on. The approach is going to be simple, friends. You just take 7 common out, 0.1, 0.11 plus 0.111 and so on up to 20 terms. You just multiply and divide with 9. 0.9 plus 0.99, 0.999 and so on. 7 by 9, friends, 0.9 can be written as 1 minus 1 by 10 plus 0.99 can be written as 1 minus 1 by 100 plus 1 minus 1 by 1000 and so on up to 20 terms. That becomes, friends, we can just 1 plus and so on 20. We can write this as 20 minus of 1 by 10 plus 1 by 10 whole square plus 1 by 10 whole cube and so on 1 by 10 whole to the power 20. This is very simple now. By using sum of finite terms of a GP, we can just get this. So I want you to simplify this particular problem, friends. Everything is same now, only this particular thing has to be simplified. My dear friends, please complete it. So whenever you come across this such sequence, make sure that you are taking whatever the integer that you have, you just take that out, multiply and divide with 9. Then make sure you are converting into a good GP one. A good GP, by using just normal formula, we can just get it. Another question. This is sounds very good and sounds interesting, my dear friends. Very good question which was asked in the year JEE 2020. Coming to this particular question, a and b the nth term of a GP of positive terms. See, sigma n equals to 1, a 2n plus 1. That is nothing but what they have given. If you put n equals to 1, a3 a3 plus A5 plus A7 and so on. If you put n equals to 200, what happens? And 100, what happens? 2 into 100 to A201 is equals to 200. Clear? Coming to the second sigma, A2, okay, plus A4 plus A6 and so on plus A200 is equals to 100. Okay, basic things we had. Now just do understand, friends, do understand. What is A3? AR square plus AR power 4 plus AR power 6 and so on. AR power 200 is equals to 200. Coming to this particular one, AR plus AR cube, AR power 5, AR power 199 is equals to 100. Friends, I am just dividing this be equation 1, this be equation 2. I am just dividing 1 by 2. You see, 1 divided by 2, what happens? Numerator I can take R common. If I take R common, everything this will be same. Yeah, see, AR cube, everything. That will be equals to 200 divided by 100. Therefore, the value of R that I can get is R equals to plus 2. Clear? See the simple approach now. Very simple. Very, very, very simple. Is that clear, friends? Now, you just take one sequence. Once you get R, you can just substitute that R here. Yes. Once you see A of like everything, A common, A out, then this is a sequence, sum of n terms, sum of a finite GP, A into R is here R square, A into R square power, how many number of terms we have? 100 terms. Minus 1 divided by R square minus 1 is equals to 200. A we don't know. R square is 2. 2 square 4 minus 1. A by 3 times R square. R square. AR square into. We can just, yes, first term is AR square. AR square. So R square is 4. We can just write 4 here. R square, that is nothing but 2 to the power 200 minus 1 equals to 200. So 4 1s are 4, 50s are, that is nothing but A is equals to 150. 150 divided by 2 to the power 200 minus 1. Please make sure you take this. Now just do understand what they are asking us to find. Sigma n equals to 1 to 200. N equals to 1 to 200 A1 AN is, the required thing is like S is equals to A1 plus A2 plus A3 plus and so on A200. If you just understand, look at this particular thing, friends. See, we have like, if you are going to add, we have everything except A1 and A201 is extra. So what I am trying to do, my required thing S is equals to sum of these two. I am adding these two. 200 plus 100, 300. I need extra A1. So plus A. A1 is A. A1 is A. And A1 is A. And I have to eliminate this 201 minus A201. So this is what my resultant thing. Hope it was clear, na? So S is equals to 300 plus A minus A into R to the power 200. Is that clear? Is this clear? Now S is equals to 300 plus A common. We get 1 minus R to the power 200. But already what is A, friends? What is A? We can just write A as, 300 plus 150 times 150 by 2 to the power 200 minus 1 into 1 minus into 1 minus 2 to the power 200 into 1 minus 2 to the power 200 into 1 minus 2 to the power 200. See, 1 ja minus 1 ja gets cancelled. 300 minus 150, then you get 150 will be our answer. Hope the thing is very clear, friends. Very simple, na? See, we just took, first we found out R, then we kept everything here. We just substituted, that's it. It might be lengthy, but if we are like, if our approach is in this way, like from the moment you read the question, if this approach is particular comes to our mind, then it comes to very particular simple part. Okay. Next, friends, consider a decreasing GP. What do you mean by decreasing GP, friends? Decreasing GP. Always make sure increasing GP or decreasing GP. Increasing means the common ratio should be greater than 1 and the common ratio should be less than 1 for decreasing GP. Okay. So that means indirectly they are asking us to select a common ratio which is less than 1, which is going to be less than 1. G1 and so on, G, such that G1 plus G2 plus G3 is equals to 13, and G1, just see, friends, like let G, okay, A, G1 be AR square, okay, AR square. Then what we get? So A plus, I mean like A common, 1 plus R square is going to be 13. Next, G1 square, I mean like A square plus A square R square plus A square R power 4 is going to be 91. Simple, friends. A square common, 1 plus R square R to the power 4 is equals to 91. Just divide this by this. 1 by 2 we get 1 by 2 we get 1 by 2, or like 2 by 1, what do we get? A square of 1 plus R square plus R power 4 whole divided by A of 1 plus R square, 91 13, that becomes 91 by 13. 13 ones are 13, 7 ja we get 13 ones, 13 sevens. So A gets cancelled. Here one more important thing that here is like very simple one. See, friends, this particular 1 plus R square plus R power 4, whenever you come across such expression, R power 4 plus R square, you write this as 2R square minus R square plus 1 as it is. This becomes R plus R square plus 1 whole square minus R square. So this finally R square minus R plus 1 into R square plus R plus 1. We have factorized this. Okay. So numerator, now we can express the numerator as R square minus R plus 1 into R square plus R plus 1 whole divided by 1 plus R square is equals to 7. This 2 gets cancelled. Now we get A of R square minus R plus 1 is equals to 7. Is that clear? Now we get this particular third equation, friends. Third equation along with first equation, you can just take divide, same, no issues. A will be eliminated. A of R square minus R plus 1 whole divided by A of 1 plus R square is going to be 7 divided by 13. A gets cancelled. Cross multiplication, then you will be getting a quadratic in terms of R. Then you will be getting R two values, but you have to select an R which is less than 1. From there, that's it. And this is, oh yeah, that might be something he'll be asking. Have you understood? Just complete the remaining part, my dear friends. I'm just assigning you this as homework. Hope this thing is clear. Is it? That's it, friends. That's it. Next part. Oh, yeah. 1 by A plus 1 by A minus. This is like a question which is based on properties. Properties based question. Here, the most important thing, whenever they give you this thing, like selection, like pairing up the terms makes the most important thing. Pairing, which two terms you are going to pair up. which two terms we are going to pair off. Sir, how do we get that particular understanding? Just by common sense, friends, just by common sense. See, if I am going to take like a and a minus 2b, already I have a here, a here. So there is no particular, like I am not going to get any particular conclusion. So if I am going to pair up with these two, see a, cb, I'll be getting an equation in terms of abc. I am going to pair up these two, same abc, so I can get something common out. In that way, a student has to think about it. Okay, now that becomes C, friends. Like very simple, 1 by a plus 1 by c minus 2b plus 1 by a minus 2b plus 1 by c is equals to 0. Then that becomes a plus c minus 2b whole divided by a of c minus 2b plus a plus c minus 2b by a minus 2b of c is equals to 0. Clear? Now this numerator part can be taken and it would be equals to 0. So that becomes 1 by a of c minus 2b. If you are going to send this to that side, 1 by c of 2b minus a we get. So that becomes ac minus 2ba is equals to 2bc minus ac. Get everything to this side, like I mean ac to this side, 2ac is equals to 2ab plus 2bc. 2 gets cancelled. That becomes, friends, divide with abc, you get 1 by b is equals to 1 by c plus 1 by a. In just be practical. If I say like something like 2 of 2 by b is equals to 2 of just something, sorry. This can be even written as 2 of, like 2 by 2 divided by 2b is equals to 1 by c plus 1 by a. Very simple. If you know like a comma b comma c are in HP, then you say 2 by b is equals to 1 by a plus 1 by c. But in place of b, here we have 2b. So hence a comma 2b comma c will be in HP. So this is how we are going to get that particular arrangement, friends. Clear? Hope it is clear. Even like I'll be just giving you a small hint for this, and I'll be assigning you for this as homework, friends. Like see, consider an arithmetic series and geometric series having 4 initial terms from that. See what are the AP and GP that we can form from them? What is the AP and GP that we can form from them? See, AP 11, 16, 11 plus 5, 16, 16 plus 5, 21, 21 plus 5, 26. Yeah, 4 terms of an AP can be found from this. Then GP 4, 8, 16, 32. Awesome, beautiful. Yeah, see the nth term of this can be like common difference is 5. So 5n plus 6. Yes, and this is going to be 2 to the power n plus 1. If the last of these are the maximum possible 4-digit numbers, okay, maximum, then the number of common terms in this they are asking. Number of common terms for an AP and GP, very important question. Just do understand. I mean like let me take this as some nth 2 power m. So to get common, 2 to the power m is equals to 5n plus 6. That means 2 power m minus 6 is equals to 5 times of m. 2 power m 5 times of n. 2 power m minus 6 is equals to 5n. Friends, 5n is nothing but a multiple of 5. 2 power m minus 6 can't be like, the unit digit can't be 5, but unit digit can be 0. 2 power m minus 6 can be unit digit 0. That means 2 power m has to end with the digit 6. 2 power m has to end with the digit 6. For which values of m it will end with 6? For which values? That means, see, like m equals to 1, 2, 3, 4, like m equals to 4, 2 power 4, 16, m equals to 8, m equals to 8, m equals to 12, and so on. But if you take m equals to 16, 2 power 16 is not a 4-digit number. They are asking only 4-digit numbers. So the maximum values of, like, the values of m that can be taken are 4, 8, 12. Hence, for m equals to 4, we will be getting a 1 term common. m8, 1 term common. Hence, we will be getting 3 terms in common for these two. This is what, like, see, this question was asked in the year 2021 as a numerical type based. Hope the thing is clear. Clear? Good. Next. So these are regarding till now whatever the things that we have discussed. General properties of AP and GP we have. AP, GP, HP we have discussed, and good good number of questions, PYQs from those concerned thing. Next, the second thing is means. We will be discussing AM, GM and HM. Coming to AM, see friends, AM is very simple. All are simple. Of this, AM is much simple. If 3 terms are in AP, then the middle term is called AM between the other two. So if A, B, C are in AP, we say B is the arithmetic mean of A and C. Now, if like for so A comma, like A, for any two numbers A comma B, for any two numbers, arithmetic mean of two numbers is A plus B by 2. AM of A comma B, A plus B by 2. AM of 3 numbers A comma B comma C is A plus B plus C by 3. AM of 4 numbers A plus B plus C plus D, sum of the numbers by total number of observations. In the same way, arithmetic mean of n numbers is always like sum of the numbers by total number of numbers. Inserting n arithmetic means between two numbers. Like, what do you mean by arithmetic means? See friends, like if I say A1, A2, A3 and so on, AN are n arithmetic means between two real numbers A comma B, between two real numbers A comma B, if and only if this sequence is an AP. This should be an AP sequence. Then only I say these A1, capital A1 to AN are said to be arithmetic means. See friends, like common sense, like basic thing. The moment you see this, first make sure that you are thorough with the common difference of this. Common difference is, which term is this? Let D be the common difference. So B will be the n plus 2th term because we have already introduced the n. So n, total n plus 2 terms we will be having. That will be our n plus 2. A n plus 2 is equals to B. A n plus 2 is nothing but A plus n plus 2 minus 1. So n plus 1 into D is equals to B. Therefore, n plus 1 into D is equals to B minus A. Hence, common difference D is equals to B minus A whole divided by n plus 1. B minus A whole divided by n plus 1. Awesome thing it is. Next. That's it. So this is how, like, when arithmetic means are inserted between two numbers, the common difference is going to be B minus A divided by n plus 1. Another most important thing, most important one friends, like sum of the arithmetic means inserted between given two numbers, that is A1 plus A2 plus A3 and so on, will be equals to n times of A plus B by 2. But what is A plus B by 2? What is A plus B by 2? Arithmetic mean, like one arithmetic mean introduced between arithmetic mean of A comma B, AM, single AM of A comma B. So n times, that is where A is the single AM between. Very important, very, very, very important. Clear? Next, geometric means. As usual, like we have seen arithmetic mean, even in, like we say ABC or in GP, then we say B is the geometric mean of A and C. But the most important thing, if both are positive, B will be root AC. If both are negative, B will be negative root AC. So that's it. n geometric means, same we say G1 comma G2 comma G3 and so on Gn are said to be n geometric means between A and B if this sequence forms a GP. If this particular sequence forms a GP, then we say that this sequence is said to be in GP. Now coming here, my dear friends, coming here, one more important thing that the most important common ratio again. An plus 2th term, An plus 2 is equals to B. So A into R to the power n plus 1 is going to be B. R power n plus 1 is equals to B by A, and R is going to be B by A raised whole to the power 1 by n plus 1. If there are like n geometric means inserted between two given positive real numbers, then the common ratio is equals to B by A whole raised to the power 1 by n plus 1. The most important one, like the product of, like there we have sum of n arithmetic means, here the product of n geometric means inserted between given two numbers, that is product of the given n arithmetic means, n geometric means G1 into G2 into G3 and so on Gn will be equals to the single geometric mean introduced between A and B raised to the power n, that is geometric mean of A comma B is root AB raised to the power n. Very important. Next friends, GM of A comma B, like for two numbers it will be like AB whole to the power 1 by 2. For three numbers, GM of A comma B comma C, three numbers multiplied to power raised 1 by 3. Four numbers, ABCD whole to the power 1 by 4. N numbers, A1 to An multiplied whole raised to the power 1 by n. So that's the important thing regarding that. Coming to harmonic mean, here like if already we have seen, if A comma B comma C are in HB, then we say B is equals to 2AC by A plus C. And the most important thing, harmonic mean for like, see, harmonic mean of two numbers is like 2 divided by the given two numbers, okay, sum of reciprocals of the given two numbers. Suppose we need harmonic mean of AB comma B comma C, so H will be equals to 3 divided by reciprocals 1 by A plus 1 by B plus 1 by C. In the same way, harmonic mean of n numbers is given by n is equals to H is equals to n by reciprocal of all those 1 by A1 plus 1 by A2 and so on 1 by an. This is the most important thing, friends. Like next, once we are done with these three, next we'll be discussing the relationship between, equality relationship between these two, that these three, that is if A comma G comma H are respectively the AM and GM and HM of two positive numbers A and B, then the relation that we have is G square is equals to AH. See friends, like if I say arithmetic mean of A comma B, I say A plus B by 2. Geometric mean root AB. Harmonic mean 2AB by A plus B. If you just see G square is nothing but AB, and A into H is equals to A plus B by 2 times 2AB by A plus B. So these two gets cancelled, that becomes AB. That means G square is equals to AH we say. That means even A comma G comma H forms a geometric progression. For any two positive numbers A comma B, even AGH forms harmonic progression, sorry, geometric progression. Next, the inequality relation between AM GM, one of the most basic inequality that we have in our sequence and series is this one, friends. Very important. Many number of problems we are going to do in this particular concept. AM is always greater than or equals to GM, always greater than or equals to HM. We can prove by just by drawing a logarithmic curve by taking x1, x2. We'll be proving that centroid lies inside this, but not, I can just prove you a very simple thing by using, for two numbers I can, like, see friends, like AM already we have seen, AM is equals to A plus B by 2 for two numbers. What about GM? Root AB. Just take A minus B, friends. What about A minus G now? A minus G. That becomes A plus B plus minus 2 times root AB by 2. a can be written as root a whole square plus b can be written as root b whole square minus 2 times root ab whole divided by 2. A square plus b square minus 2. That means root a minus root b whole square divided by 2. See, this is completely positive one because square of something na. A minus g is square of something. That means a minus g is positive. If a minus g is positive, what can we say? A is greater than g. In the same way, we get a equals to when we get equals to when a equals to b. So this is very important. The equality holds when all the given numbers are equal. All the given numbers have equal values. When the given numbers have equal values, then we say equality. In all the other cases, am will be greater than or equals to gm will be greater than or equals to hm. Very most important inequality that we have in our sequence and series. This particular inequality relation, we not only go with this sequence and series, more or less like till completion of 3D vectors we use this AMGM inequality. Very important. So I want everyone to understand this rather remembering the final thing. Understand it, then remember. Okay, because whenever you understand a particular thing, that makes you feel, that makes you to understand the flavor of that particular subject. Clear? Next we'll start doing problems, friends. AM of two numbers exceeds the GM by 2 and GM of the same numbers exceeds the HM by 8 by 5. Find the numbers. Find the numbers. See friends, like let A be AM of A comma B, G be GM of A comma B, H be HM of A comma B. In that case, what did they say? AM of two numbers exceeds the GM by 2. So A equals to G plus 2. Clear? Okay. Next, AM of two numbers exceeds the GM and GM exceeds the HM by 8 by 5. H plus 8 by 5. We have very simple relation between them is G square is equals to A into H. G square is equals to, what is A? Here we got G plus 2. What is H? G minus 8 by 5. That becomes G square is equals to G square minus 8G by 5 plus 2G minus 16 by 5. That becomes G square gets cancelled. So 16 by 5 to this side. That becomes 5 to 10G minus 8G. 2G by 5. G will be equals to 8. G is 8. See friends, if G is 8, A will be 10. A is nothing but arithmetic mean is equals to 10 and geometric mean root AB is equals to 8. So A plus B is equals to 20. AB is equals to 64. Product 64, sum 20. What will be the numbers, friends? I guess. Not guess. 16 comma 4 is the only possibility. 16 plus 4 20 and 16 4 is 64. Hence the given two numbers are 16 comma 4. Hope everyone understands. Simple, by using the simple property relationship between equality relationship between A comma G comma H, then we discussed this. I hope it is making sense and it is clear. Good. Next case, let G be the geometric mean of two positive numbers A and B and M be the arithmetic mean of 1 by A comma 1 by B. If 1 by M is to G, they have given 4 is to 5. They are asking us to, this was asked in the JEE 2014, friends. Like I'll just give you some hint. Okay, we'll complete it, no issues. See friends, like G be the geometric mean of two positive numbers. So G will be equals to root AB. And M is the arithmetic mean of 1 by A comma 1 by B. M is the arithmetic mean of 1 by A comma 1 by, that is 1 by A plus 1 by B whole divided by 2. That's it na. M is equals to, that is A plus B by 2AB. Just simplify. Now they are asking like 1 by M is to G is equals to 4 by 5. 4 is to 5. What is 1 by M? That is 2AB by A plus B whole divided by G. G is root AB is equals to 4 by 5, friends. Cross multiplication, 5 to 10AB divided by A plus B is equals to 4 times root AB. Clear? Squaring on both sides. 4 by 5. Correct only na? Everything? 2s are 5s are. So 25 AB whole square by A plus B whole square is equals to 4 times of AB. AB gets cancelled. Then this, so 25 times AB is equals to 4 times A plus B whole square. That will be 4A square plus 4B square plus already 2AB. 4 2s are 8AB we get. So finally everything to the side we get 4A square plus 4B square. 8 minus 25 we get 17 minus 17 AB is equals to 0. Friends, they are asking us to get the ratio of A is to B. For that, just divide both sides with B square. Then you get 4 of A by B whole square plus 4 minus 17AB by, so 17A by B is equals to 0. That's it, friends. Okay, just take A by B as some P or K. A by B is equals to some K for some instant. Then you get a quadratic equation in K. 4K square minus 17K plus 4 is equals to 0. We can factorize minus 16K minus K. That's it. From there you will be getting the value of A by B. Clear? That's it, friends. So just complete this particular part. I'm just giving you as homework. Hope you will do it. Yes? Very good. Next question. M is the arithmetic mean of two distinct real numbers L and N. So that will be M is equals to L plus N whole divided by 2. The moment you see, just whatever the conclusion that you can just write it. And G1, G2, G3 are be three geometric means between L and N. That means L comma, G1 comma, G2 comma, G3 and so on N forms a GP. Forms a GP. Now they are asking G1 square plus, see friends, very simple this one. These three are in GP na? Like if these three are in GP, can I write G1 square is equals to L times G2? In the same way, these three are in GP na? G3 square is equals to N times G2. Okay, now see, again, we can even take L, G2, N. The terms of a GP chosen at regular intervals will also be in GP again. So that means L, G2, N can also be in GP. We can write G2 square is equals to Ln. Now by using all these, just substituting here. What is G1 power 4? L square into G2 square. 2 times of G2 power 4. What is G2 power 4? L square, N square. Plus G3 square is already N G2. So N square, G2 square. Acha. N square, G2 square. Now L square, G2 square is Ln. Plus 2 times L square, N square. Plus N square times Ln. Ln common. L square plus 2Ln plus N square. That becomes Ln of L plus N whole square. But L plus N is 2M. So 4M square Ln. We even used this now. See, the thing is very simple, friends. The thing is very simple. Properties of AP, all those, and AM, GM, HM properties. Then we solved this particular question. Next, XYZ be three positive real numbers. Yeah, another important and like extreme important problem, which tells us to use AM, GM inequality. See, friends, like whenever they give you like a sum they have given. See, friends, and x cube y power 4 z power 5. Very important in those cases, like whenever they give you this like x cube into y power 4 into z power 5, the thing is we don't know like x cube y power 4 z power 5, but express these like given, like take the numbers. X cube means x can be written as x by 3 plus x, like x by 3 so y plus, Now let me take, see, the numbers that I can take are x by 3, x by 3, x by 3, because power 3 no, so I have just written, we have to use this in this case, y power 4, so y power 4, y power 4, y power 4, sorry, y by 4, z by 5, z by 5 into z, comma, z by 5, comma, z by 5, comma, z by 5, comma, z by 5. See, now I am going to take this as my input numbers. How many numbers I have? 1, 2, 3, 3 plus 4, 7, 7 plus 5, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers I have. 12 numbers I have. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers I have. These 12 numbers, now I am going to take as they are my input numbers. Input numbers. Now for these numbers, what will be the arithmetic mean of these 12 numbers? Their sum divided by 12. Their sum divided by 12. But what is their sum already? X by 3 plus x by 3 plus x by 3 is x. So x plus y plus z is already 12, which is equals to 1. Clear? I'll find geometric mean also. What will be the geometric mean of these? That is x cube by 3 cube into y power 4 by z, like 4 power 4 into z power 5 by 5 to the power 5 whole to the power 1 by 12. This is equals to, but x cube y power 4 z power 5 value is 0.1 times 600 cube. Divided by 3 cube, 3 into 3 into 3, 4 power 4, 4 into 4 into 4 into 4, next 5 power 5, 25 into 25 into 5, whole power 1 by 12, 1, 1, 1, 200, 200, 200. 25 ones are 25 eights are. Okay, 25 eights are. 4 ones are 2s are. 2 2 again 1 4 gets cancelled. Yes. Now we are left with 1 4 and 1 5. Yeah. 5 4s are 20. 10 ja. 10 into 0.1, 1. That is 1 power 1 by 12, which is also 1. Friends, here AM of these 12 numbers is equals to GM. AM of these 12 numbers is equals to GM. What do you mean by that? AM will be equals to GM in only one case, when if all the given numbers are equal. That means x by 3 is equals to y by 4 is equals to z by 5. This, all these numbers I am just equating this to some k. So that means x is equals to 3k, y is equals to 4k, z is equals to 5k. Sum put here, 3k plus 4k, 7k, 7k plus 5k, 12k, 12k is equals to 12, k equals to 12. That means x equals to 3, y equals to 4, z is equals to 5 I got. By substituting these values in this, we get the required thing. X cube plus y cube plus z cube, that is 3 cube plus 4 cube plus 5 cube. See, the concept here which we have used is AM is found to be equals to GM. It happens only in one case. That means all the numbers are equal. Then we got this particular approach, friends. Clear? Yes. Another problem which involves the same AM GM inequality. How do you know that, sir, approach, like we have to go whether with AM GM inequality or not? That tells us very simple, friends. We get to know about it only in one case. Like the given two numbers are found to be like, one is like some x, the other will be its reciprocal or something by reciprocal. In all these particular cases, you will be understanding that you are supposed to use AM GM inequality. Now, friends, the maximum value of this expression, I have numerator x power m. So I'm just writing this as, I brought everything to this side. So 1 plus x to the power 2m, I brought x power m to the denominator. Do you agree? Yes. 1 plus y to the power 2n by y power n. Now this becomes, friends, this becomes 1 by x power m plus x power m into 1 by y power n plus y power n. Clear? Clear? Now just take these two as my numbers. Okay, these two as my numbers. If I take like am and gm, 1 by x power m and x power m as two numbers, 1 by x power m plus x power m, am of these two is always greater than or equals to its geometric mean, 1 by x power m into x power m. So 1 by this will be always greater than or equals to 2. Clear? This will be always greater than or equals to. This will be always greater than or equals to 2. So this particular, now we need maximum value of this, means the denominator should be minimum. The denominator should be minimum. What will be the minimum value of the denominator? 4. Hence the maximum value of this complete expression is 1 by 4. To get the maximum of whole, we need minimum of denominator. The minimum of denominator is 4. This was asked in the year 2019, friends. Then find the greatest value of this particular expression. Same again, but here identifying that as AMGM inequality, at the same time try to express the given thing in terms of that. Okay, in terms of that. Now just do understand this, friend. Whatever the numerator that we have, divide with the denominator. That becomes 1 by x power 100. That becomes 1 by x power 100 plus x by x power 100. So 1 by x power 99 plus 1 by x power 98 and so on. Here somewhere you will be having x power 100 also. So x power 100 by x power 100, x1, then x power 101 by 100, x power 1 plus x square and so on. X power 200 by x power 100, you get x power 100. Just look here, friends. Basic thing here. Basic thing. See, from here to here, we'll be having 100 terms. From here to here, we'll be having 100. So in total, we'll be getting 201 terms. Total, we'll be having 201 terms. Now for this 201 terms, look at the approach. How the approach is going to be, see. Look at the approach. Just look at the approach, friends. Just look at this particular approach. Now if I am going to take for all these 201 terms, this, like, let me take this complete denominator as some e. Okay. Now this e whole divided by AMGM inequality. E, sum of the numbers by total 201 is greater than or equals to its geometric mean. What will be its geometric mean? See, everything it's being multiplied. 1 by x power 100 into x power 100 gets cancelled. 1 by x power. So that becomes 1 to the power 1 by 201. That means E will be always greater than or equals to 201. So the minimum value of this denominator is 201. To get the greatest value, denominator should be the minimum. That means the maximum value of this is 201. 1 by 201. Understood, my dear friends? Understood? Good. Next, this is like the same that we have done in the same problem which we have done just 2 problems before. See, a plus b. Now they are asking a square into b cube into a. Let me express a as like power 2, no? So just 2 terms. So a by 2 comma a by 2, b by 3, b by 3, b by 3, c by 2, c by 2. Clear? Now that becomes, friends, AM greater than or equals to GM for the given positive numbers. Now if I take AM of these, how many numbers I have? 1, 2, 3, 4, 5, 6, 7. For 7 numbers, these sum by 7 greater than or equals to their product. A square by 4 into B cube by 27. That means, why? 1 second. Let me write 2 square on it. 2 square 3 cube into c square by again 2 square whole to the power 1 by 7. But this value is already 3. Some 3, no? So 3, now power 7 on both sides. 3 power 7 divided by 7 to the power 7 is always greater than or equals to a square b cube c square by 2 power 4 into 3 cube. This becomes, friends, a square b cube c square is always less than or equals to cross multiplication 3 to the power 10 into 2 to the power 4 divided by 7 to the power 7. Greatest means, so this is always less than or equals to, this will be the maximum value of this particular expression. Hope you understood, guys. Yeah, good. The same again, I'll just give you this as homework. This was asked in the year 2021. My dear friends, like a to the power a power x plus a, like a power 1 minus like this can be a power m minus n. So a power 1 by a power x. Again, for these two, you just take AMGM inequality, then you get the result. Okay, you will do this. Yes. Next question asked in the year 2021. AM and GM of pth and qth terms of a sequence, some sequence they have given, satisfy the equation. So just 4x square minus 9x plus 5 is equals to 0. 4 5 is 20. So 4x square minus 4x minus 5x plus 5 is equals to 0. Factorize this particular expression. Now you get 4x of x minus 1 times minus 5 of x minus 1 is equals to 0. X minus 1 into 4x minus 5, 0. So x1 and x is 5 by 4. Friends, basic common sense. Dear friends, the basic common, see here the roots are, one is AM, one is GM. But how do you identify what is AM, what is GM? AM is always greater than GM. AM is always greater than GM. That means this is AM of those two terms and this is GM. Now find out like what is that TP, pth term in that, pth term in this particular sequence. A into, what is A? Minus 16 into R to the power P minus 1, and TQ minus 16 into, sorry, we know R, no? We know R. What is R? 8 by negative 16. So minus 1 by 2 to the power P minus 1, and TQ is equals to, TQ is nothing but minus 16 to the power minus 1 by 2 to the power Q minus 1. Friends, the geometric mean of these two terms is found to be 1. That is root of TP into TQ is 1. Squaring on both sides. That is TP into TQ is going to be 1. Why? Because they have given the geometric mean and arithmetic mean of those two terms is going to satisfy this equation. First we found GM and AM, then we are getting this. So TP into TQ, that is 16, 16s are 256 into minus 1 by 2 to the power P plus Q minus 2 is equals to 1. That becomes minus 1 by 2 to the power P plus Q minus 2 is equals to 1 by 256. 1 by 256 can be written as 1 by 256 can be written as 16 square, 16 is 2 power 8. So 1 by 2 whole to the power 8. Even this can also be written as minus 1 by 2 power 8. Now, when bases are equal, powers can be equated. So P plus Q minus 2 is equals to 8. P plus Q is equals to 10. See friends, such a beautiful question it is. See, first they have given roots. From there we have identified what is GM, what is HM. We have taken this as the criteria to get this. And they are just asking us to get the value of P plus Q. Hope you understood, guys. I hope you understood. Beautiful. Yes. Now we are done with AM, GM, HM. All the basics things, problems, AP, GP done. Now going with another stepping thing. AGP, we say Arithmetico-Geometric Progression. Arithmetico-Geometric Progression. So a series in which like the corresponding terms of an AP and GP are being multiplied. I'll tell you the simple thing, friends. See, Suppose 1x, x square, x cube and so on. It's a GP. Next I have something like 2, 4, 6, 8 and so on. It's an AP. This is GP, this is AP. Now the corresponding terms of an AP and a GP are being multiplied each other. If you are going to multiply the corresponding 2 into 1, 2, 4x, 6x square, 8x cube and so on. This particular sequence is said to be AGP. Friends, AGP is very simple. You trust me, AGP is very simple. How? Because the only one particular basic thing that we are going to do in AGP, we are not going to remember any formula, nothing, only the approach. The approach is very simple. Whenever they give you an AGP, first make sure that you should be in a situation to identify is that AGP or not. Then after identifying this as AGP, the second thing that you're supposed to do is identify R, common ratio. Common ratio. Once you identify that common ratio, multiply the common ratio with both sides of that SN, then you subtract, you will get the required thing. Very, 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 very simple. Cool? This is how AGP. To find Sn or S infinity, multiply Sn or S infinity by common ratio and subtract both the series. Fundamental. This is basic fundamental of AGP series. If you know this, any problem, irrespective of any problem, friends, any problem you can do it. Any problem. Now we'll see the questions. That's it. The sum to infinity of the sequence. This was asked in the AIEEE 2009. See friends, first you have to understand whether the given sequence forms an AP or not. Sorry, forms an AGP or not. Look here. See, 2, 6, 10, 14, these are all in AP. And 3, 3 square, 3 cube, 3 power 4, these are all in GP except this first term 1. So just eliminate it. Keep it aside. Then you concentrate only on the remaining terms. At last for the sum you can just add 1 to the final one. You understood? That's it. Now just take, I'm just going to take this as S infinity. Sum S is equals to 2 by 3 plus 6 by 3 square plus 10 by 3 cube plus 14 by 3 power 4 and so on up to infinity. See, remember, add 1 to the finals. Yes, that is what we need. Now, what I said, the basic fundamental, whenever we come across an AGP, friends, whenever we come across an AGP, the first thing you should identify is R. What is R in this case? 1 by 3. Now multiply 1 by 3 with both sides of the S. So 1 by 3 into S, that is S by 3 will be equals to 2 by 3 into 1 by 3. 2 by 3 square, 6 by 3 square into 1 by 3. 6 by 3 cube plus 10 by 3 power 4 and so on up to infinity. Now subtract them, friends. S minus S by 3 will be 2S by 3 is equals to 2 by 3 times plus 6 by 3 square minus 2 by 3 square, everything 4 by 3 square, 4 by 3 cube, 4 by 3 power 4. I am just taking 4 common, 4 of 1 by 3 square plus 1 by 3 cube, 1 by 3 power 4 and so on up to infinity. So 2S by 3 will be equals to 2 by 3 plus 4 by 9, 3 square common, then you get 1 plus 1 by 3 plus 1 by 3 square and so on. You can even take, you took 3 square common. This, have you understood one thing? This is an infinite GP. A by 1 minus R. This sum is going to be A by 1 minus R. 4 by 9 times A by 1 minus R. That is 1 by 1 minus 1 by 3. So 2 by 3. 2 1s are 2s are, 3 1s are 3 3s are. 2 by 3 plus, which implies 2S by 3 is equals to 2 by 3 plus 2 by 3, that becomes 4 by 3. 3 gets cancelled, 2 1s are 2 2s are, S is equals to 2. But finally what? Yes, adding 1 to this particular, hence the correct answer is option D, which is equals to 3. Understood, friends? Because in the beginning we have We have not included 1. We just took only from this. So just do it. Some majority of the students will be thinking even like 1 is included. Which type? This is not AGP. No, they'll be just stucking there itself. Don't waste your time in that particular way. Clear, clear, clear. Good. Awesome, friends. Awesome. Next, the sum k equals to, again an AGP problem. Again an AGP problem. This was asked in the year 2019. See, such an interesting and beautiful one, friends. Beautiful one. I'll just give you the approach, the remaining. Okay, as this is not infinite, like I'll go with this. Sigma k equals to 1 to 20. I mean, sigma means summation, friends. So let S is equals to first k1. That is 1 into 1 by 2 power 1 plus 2 into 1 by 2 power 2 plus 3 into 1 by 3 to the power 3 and so on up to 20. 20 into 1 by 2 power 20. This is what we need. Okay. I already told you. Okay, this is clearly an AGP. With what is the common ratio? 1 by 2. I already told you, friends. Whenever you come across an AGP, the most important thing, identify R and multiply it both sides. That's it. Ho gaya. So 1 by 2 into S is equals to 1 into 1 by 2 square plus 2 into 1 by 2 cube. Sorry. 1 by 2 cube plus and so on. 19 into 1 by 2 power 20 plus 20 into 1 by 2 power 21. This is what we will be getting, friends. Now S minus S by 2 will be again S by 2. You get 1 by 2 plus 2 minus 1. 1. So 1 by 2 square plus 1 by 2 cube 1 by 2 power 4 and so on. Here 1 by 2 power 20 plus 20 times 1 by 2 power 21. You understood? You understood? Now this is found to be in GP. This is found to be in GP. You just take sum of a finite GP a into r power n minus 1 by r minus 1 and just complete it and simplify it in a proper way to get finite GP. This is like homework, my dear friends. Hope you will complete it. Just complete the remaining part. You will just feel awesome about it. So in AGP, very simple. Only one particular approach. Only one. Identify AGP in a proper way. Then identify R. Multiply that R both sides. Then subtract the two series. You will be getting the required because you'll be that will be converted into GP. From GP we know simply we have AGP formula for n terms and infinite, but we never include, friends. We never include AGP problems, AGP formula. That's a hard thing to memorize. No, don't memorize the things. Okay. Next, the sum of the infinite series, friends. The same as we first problem. So I'm just assigning you this as for homework. Please make sure you complete it. Okay. Please, please, please. Again, I'm just telling you, my dear friends, I'm requesting you to complete this. Clear? Next, sigma notation. Another important topic that sigma notation. Very important, friends. Sigma. Sigma means summation, friends. Sigma means summation, we say. This is denoted by this particular letter. This is an operation, we say. Operation. This is an operation. Sigma means summation. Sigma means summation. We have some specific theorems in this sigma. What are they? Main means like sigma. For sigma, we will be having an input, friends. Sigma will be having an input. Suppose if I say sigma like r equals to 1. So sigma, now I have to find a variable r in this particular operation like log of x. X is my input. Here for sigma r is going to be my input. Okay. Sigma r equals to 1 to 5. If I say r square, that I mean to write 1 square plus 2 plus comes like first you take r equals to 1, then again it approaches here and this is what our plus. Continuous summation. Then again once you come here, again it comes here, r after 1 2 plus 3 square till where? Till 5 square. Understood? So this is what the purpose of sigma, continuous summation. Even in we say pi, continuous product we say. Some theorems, some basic properties of sigma. First one is whenever we have sum like this, sigma r equals to 1 to n, some ar plus br, we can separate them, friends. Sigma ar plus sigma br. Sigma AR plus sigma BR. Whenever they give you like this, okay? Sigma, next, if a constant is being multiplied with our input, just take that constant out, then you can write everything as it is. Next, one more thing, sigma r equals to 1. Here we don't have any r input. In that particular case, you write n times, means how many number of terms we are taking. Number of times the sigma is being operated into k, n times k. And many students, my dear friends, will be doing this sin. Sin means pop. Don't do this pop. What is that pop means, friends? Suppose if I have sigma r power 5, majority of the students will be writing some r cube into r. So sigma r square into sigma r cube they write. This is never be equal. And even division too. Sigma can be splitted only for addition and subtraction only, not for multiplication and division. Don't commit this pop, don't commit this sin, my dear friends. I say again, please do remember this. Sigma is only for summation, only for addition or subtraction. Yeah, some standard results in sigma, we say sum of first and natural numbers, like already we might be knowing it. Sigma, sum of first and natural numbers, we can prove them by using method of difference, which we will be discussing in the next consequent topic. Standard results of sigma, we say sum of first and natural numbers n of n plus 1 by 2, sum of the squares of first and natural numbers n of 2n n plus 1 into 2n plus 1 by 6, and sum of the cubes of the first and natural numbers, we say n square into n plus 1 whole square whole divided by 4. This can even be written as like sum of the square of sum of first and natural numbers. Please make sure you take a screenshot or else you just note them, because we'll be coming across all these three very fundamental thing. Unless and until you are clear, we can't solve this sigma problems and sum to n terms or method of difference. None of the problem we are going to solve. Okay, next, apart from this, like this is not necessary at all. This is not necessary. I mean, don't star mark means not that. Not necessary at all. Yes, again, this is important, friends. Like sum of odd natural numbers. Yeah, r square. How we got this? By using just by sigma problem only. Like see, sigma 2r minus 1. Then we get sigma 2r minus sigma 1. 2 times of sigma r minus sigma 1 is n. What is sigma r? N into n plus 1 by 2. N into n plus 1 by 2. So this becomes n square plus n minus n. Just by using our sigma, these three are the main key ones. Main key one. Now by using these three, we can just get any sequence, any summation, and just remember this, so that will like time saving. Sum of first odd natural numbers n square, sum of first even natural numbers n into n plus 1. Major like sigma, we go like this, sigma r of r plus 1. This is also again like by no need to remember, approach is same, like sigma r square plus sigma r. Okay, sigma r square plus sigma r. Then you just simplify summation, you will be getting it. This is already we have seen, this is an AGP. For AGP, what we did, just identifying r and multiplying it both sides of the yes, then we'll be simplifying it, then we'll be getting it. That's it. Very good. So next we'll be going with problems from sigma notation. See, my dear friends, sigma problems are very simple. For this, now coming to the first problem, this was asked in the year JEE 2013, and the question is sum of the series of this up to 10 terms. First, you have to identify in every sigma problem, you have to identify the nth term. And apply summation to that nth term. Okay, clear? Yes, right. See now, this is like 1 into, like see, this 1 into 2 square plus 2 into 4 square 3 into 6 square. Can I write this nth term like an is equals to n into 2n whole square? See, for n equals to 1, 1 into 2 square, n equals to 2, 2 into 4 square, n equals to 3, 3 into 6 square. This becomes n into 4n square. This becomes 4 into n cube. That's it. We got the nth term. Now to get Sn, friends, to get Sn, just apply summation to sigma. Sorry, summation to an. That becomes sigma 4n cube. That becomes 4 times of sigma n cube. Dear friends, what is sigma n cube? Sum of the cubes of the first n natural numbers. That becomes 4 times n square into n plus 1 whole square by 4. 4 gets cancelled. Now we need S10 na? Put n equals to 10 now. Though they are asking S10, don't ever put S10 directly. First you get San, then find Sn, then you put n equals to whatever the required thing. 10 square into 10 plus 1 whole square, 11 square. So that itself is our problem, friends. So that is 121,000. Very simple problems. For sigma related sums, approach is going to be very simple. But how do you identify whether it is sigma? First you will be checking whether it is AP or GP. It's not, then AGP we check. If it is not AGP, then no doubt it will be of sigma. Some will be cases, though they are sigma, we are not able to approach sigma. In that case, we will be going with method of difference. In that case, we will be going with method of difference. In that case, we will be going with method of difference. Clear? Next problem. 1 square. Just now we have discussed different. Just now we have discussed some of the squares of first odd natural numbers. But how many odd natural numbers we have? How many odd natural? Which term it is? Like n is equals to 25. Directly n square. But which term it is? An is equals to 25. All these are some of the squares of odd natural numbers. My dear friends, like I just okay. Here first, this is an odd sequence, odd number sequence. First find nth term, an, like find nth term. Find nth term. An is equals to 2r, like 2n minus 1. This is our nth term. Is this? No. Square of this will be our nth term. Clear? Square of this. Put n1 satisfies, n2 satisfies. So this becomes 4n square minus plus 1 minus 4n. Apply. To get Sn, just write sigma to this, friends. Just write sigma an. That means 4 times sigma n square plus sigma 1 is n directly minus 4 times sigma n. Now we need which term it is. Which term we will be getting, like 2 into 13. 13, 26. So this is 13th term. Correct? N equals to 13. Later we will be substituting S13. First we simplify this. What is n square? N into n plus 1 into 2n plus 1 whole divided by 6 plus n is n itself minus 4 into n of n plus 1 whole divided by 2. Okay, 2s are 3s are 2s are 2s are. Now put S13 is equals to 13 into 13 plus 1, 14 into 13 2s are 26, 26 plus 1, 27 divided by 3 plus 13 minus 2 times 13 into 13 plus 1, 14. Friends, that's it. Like you can just simplify it, okay, and get the required thing. Approach is very simple. And the thing is here, get the nth term of that particular sequence, apply summation to that. Ho gaya. Clear? Next thing, the sum of first 9 terms of this particular series. Sum of first 9 terms of this particular series. Sum of the first, as usual again. Sum of 9 terms or any number of terms we have. Any number of terms we have, friends. Sum of 9 terms or any number of terms. I repeat again. Any number of terms. Friends, first find the nth term. What is the nth term? 1 cube plus 2 cube plus 3 cube plus and so on plus n cube whole divided by 1 plus 3 plus 5 plus and so on 2r minus 1, 2n minus 1. That becomes, numerator is sum of the cubes of the first and natural number, sum of the cubes of the first and natural numbers. That is n square into n plus 1 whole square divided by 4 whole by, this is sum of first odd natural numbers, n square, first and odd natural numbers. So directly we got n plus 1 whole square divided by 4. Now we will be applying summation to this, means that means n square plus 2n plus 1 whole divided by 4. Just sigma Sn is equals to sigma an, that is nothing but 1 by 4 times sigma n square plus 2 times of sigma n plus sigma 1. Friends, 1 by 4 times, what is sigma n square? What is sigma n square? What is sigma n square? N into n plus 1 into 2n plus 1 whole divided by 6 plus 2 times of n into n plus 1 by 2 plus n. Now put n equals to 9. Now put n equals to 9 because they are asking only sum of first 9 terms. Put n equals to 9, you will be getting it. Is that clear, friends? Such an easy questions, friends. Sum to n terms is very easiest problems. Clear? Good. Friends, directly, like it was given directly, just very simple. It is like what we say, we just multiply it, sigma r square, use the formula, you get it. Okay, I'm not going to do this, so I'll just give you this as homework. This problem also homework, same again, get the nth term, this was asked in the year JEE 2018. Get the nth term and do it, friends. Get the nth term. If you are having doubt, put it in the comment section. I am there to guide you. No doubt at all, friends. So some of the again. See, friends, like this 6 can be expressed as something like 6 of 1 square plus 2 square by 5. Correct? Yes. Hope you agree. Yeah. Now see, this from here you just eliminate that one, no issues. Okay, or even like you can even take one more particular term. Just see, friends, 1 as it is I have written. What I did, that 6 as 6 of directly 1 square plus 2 square by 5 I have written. Before sum I am just writing 3 as 1 square by 3, 5, 7. No, 3 I am writing. Have you understood this? Oh, like no, not necessary. This one itself as 3 of 1 square divided by 3 plus 9 times of 1 square plus 2 square plus 3 square whole divided by 7 and so on. Now up to 15 terms they are asking. Make sure that you are getting the nth term itself. Nth term makes everything, friends. Nth term. What can be the nth term, friends? See, nth term is like first 3, 6, 9. All these things are in AP. The two multiples of 3. So 3n. Clear? Clear. And this is like 1 square plus 2 square. So for n square it will be 1 square plus 2 square plus 3 square and so on plus n square whole divided by 3, 5, 7 and so on. 3, 5, 7 and so on. This is something like AP. This is an AP and that too, this sequence will be of 2n plus 1. Clear? 3n, 3, put n equals to 1. Yes, 4. Yes, very good. Now that becomes an will be equals to 3n times. What about this? N into n plus 1 into 2n plus 1 whole divided by 6 times 2n plus 1. 2n plus 1, 2n plus 1 gets cancelled. 3 1s are 3 2s are. Finally, that becomes n square into n plus 1 whole divided by 2. Clear? See, we are not done. That becomes 1 by 2 of n square into n cube plus n square. Friends, my dear friends, directly I am writing. Directly, now you get Sn is equals to sigma an, that is nothing but half of sigma n cube plus sigma n square. You know what is sigma n cube? You know what is sigma n square? Everything in the same. Everything same again now. Everything. See, after substituting the formula, put n equals to 15. You will be getting the required. My dear friends, you complete this. Are you able to follow the approach? because my dear friends, the approach is simple. Approach is very, very simple. Okay, good. Next one. See here also, now for this I am giving you everything. Identify the nth term. See 3, 5, 7 AP 2n plus 1 directly. Okay, I am giving you that 2n plus 1. This one is cubes na. Sum of the cubes of first and natural numbers, 1 cube plus 2 cube plus 3 cube and so on plus n cube whole divided by sum of the squares of first and natural numbers. So that becomes 2n plus 1 times n square into n plus 1 whole square whole divided by 4 by n into n plus 1 into 2n plus 1 whole divided by 6. Yes. 2n plus 1, 2n plus 1, n plus 1, n plus 1, n, 2s are 3s are, that comes to the numerator. Now an will be equals to 3 times of n plus 1 divided by 2. That's it. See how much simple it became now. What a simple problem it is now. Just apply summation to this, you will get Sn. Now he is asking the sum of yes. That's it. The sum of this particular sequence they are asking us to find. They might be giving, something is missed, friends, like they might be asking like sum of first 20 terms or 10 terms. According to that we can just substitute the n value and we get it. Okay, clear, very good. Next, so even I'm just giving you to complete this as homework. They'll be giving you like sum of like first, I'm giving you this question, sum of first 10 terms. Okay, go with that. You will get. Here also again directly first get the Sn. What is S? Like what is an? 1 plus 2 plus 3 plus and so on plus n. That is the nth term. Okay. What is now an is equals to n into n plus 1 by 2. Apply summation to this, you will be getting. But n equals to 20 here. Only sum of first 20 such terms we are supposed to find. Okay, very good. Now, okay, even I am just including this as homework, friends. Okay, just very simple na. Like Sn will be equals to 1 by 2 times 1 by sigma an. That becomes 1 by 2 of sigma n square plus sigma n. You know what is sigma n square, you know what is sigma n, then just substitute that, you will be getting it. Complete the incomplete, my dear friends. Here also everything. Directly in this particular question, they have given nth term itself. Now they are asking us to find Sn. You understood? Now first you have to simplify this Sn. How do you simplify this Sn? Let me take this as some an, friends. Okay, for some time, let this be n of n plus 1 into 2n plus 1 whole divided by 4. Clear? Now that becomes C, friends, like 1 by 4 times n into n plus 1, that is n square plus n into 2n plus 1. Now you just do understand 1 by 4 times n square into n, 2n cube, n square into 1, n square plus 2n square, that will be 3n square plus n. Ho gaya? Now that becomes Sn finally 1 by 4 times 2 times sigma n cube plus 3 times sigma n square plus sigma n. So, you know the formula of sigma n cube, sum of cubes of natural numbers, sum of squares of natural numbers, sum of first and natural numbers. After that, you put n equals to 7 because they are asking only sum of first 7 terms in that. Don't put everything. Clear? Complete even this too, my dear friends. You have got enough potential to solve such sums. Enough potential. Now this is again the same again. Make sure that you are able to get the nth term of such a sequence. And get the Sn. Sn means S11 they are asking. Sum of first 11 terms only they are asking. Even I am just alerting you at this as homework. This was asked in the year JEE 2019. The pattern of these sigma notation sums is very easy, friends. Find, observe the sequence, try to able to get an, apply summation to that, you will be getting Sn. Put n equals to the required thing, sum of first 20 terms or 15 terms or 7 terms according to the requirement. This is like one, we did this, We did this already, but just kidding this. Just see this. Look at this, friends. Just look at this. They want this sum minus this sum. We'll be finding this separately and that separately. For that, first we'll be, what is the nth term of this, boss? What is the nth term of this? Sum of the cubes of natural numbers, n square into n plus 1 whole square by 4, and denominator is n into n plus 1 by 2. 2 1s are 2 2s are n square. So that becomes n into n plus 1 by 2 we get. Okay, clear? Now for this we are supposed to apply sigma, friends. Okay, we'll get this sigma an, that is nothing but first S15 I am taking. S15 is equals to, for this only I am taking only this, S15 is equals to first 1 by 2 of sigma n square plus sigma n, na? 1 by 2 times, what is sigma n square? N into n plus 1 into 2n plus 1 by 6, that is 15 into 16 into 31 divided by 6 plus 15 into 16 divided by 2. Okay. Now once you get this, this is directly one simple one. This is like 15 into 16 whole divided by 2. 15 4s are 60. You just subtract 60 from this, you will be getting the required thing. Hope you understood, friends. Sigma related sums are much simple things, friends. Much simple things. The purpose of them is very easy. Just identify the sequence, get the nth term. After getting the nth term, apply summation to that, then you will get Sn. After getting Sn, substitute the value of n, whatever the required thing we have. That is regarding some sigma notation problems, friends. And the last topic in this particular session, very important topic actually, very important, is method of difference. Sir, why to do this, friends? We have seen AP, GP, HP, AGP, some related questions and all. Coming to this method of difference, we have seen from beginning, if a sequence is AP, GP, then we'll be directly going with the sum of them. AGP directly. If it is not either of AP, GP or AGP, then we'll go with this identifying able to, like we can able to identify nth term, that's fine, cool. But though we able to identify and apply sigma, there are, see, you know sigma n cube. But can I, if I say sigma of 1 by n cube? No. For such questions, method of difference plays very important role. Very important role. And this is like, see friends, very simple. Method of difference. I'll tell you the most important thing. Coming to method of difference, friends, method of difference, what you are supposed to do. First, get the nth term, okay? For a sequence, we have a sequence like we have an f of x as a sequence, f of n. Okay, we have a sequence. Get nth term. Get the nth term, first thing. The moment you get nth term, you have to express that nth term as the sum or like sum of the like difference of two consecutive terms. Whether it can be two consecutive or four, anything like difference of consecutive terms. I repeat, difference of consecutive terms means n has to be expressed as like f of n minus 1. Clear? The given sequence they will be giving you, that sequence has to be identified and you have to express that an as some difference of consecutive terms. Now you see, suppose like sigma of f of x, like from n equals to 1 to some n you take. See, this will be like, put 1, f of 1 minus f of 0 plus, put f2, f of 2 minus f of 0 f of 1, sorry, plus f of 3 minus f of 2, and so on. You get f of n minus f of n minus 1. Now you just do understand, friends. F of 1, f of 1, f of 2, f of everything gets cancelled. Everything gets cancelled. Only the inputs with minimum and maximum inputs, only the functions with minimum and maximum inputs will be left over. That is f of n minus f of 0. This sum has been completely reduced to f of n minus f of 0. Very simple, na? You understood? Now in this process of expressing the given an as sum of or difference of two consecutive, I can't tell you like one single approach will be going to make everything, but no, but I'll tell you one standard approach. That standard approach is like, once the an you get, you factorize the denominator of that an. Once you factorize the denominator of that an, write the numerator as the difference of highest and least factors of the denominator, and balance it everything. Okay, we'll discuss everything here. We'll discuss. See friends, this is one particular sum from method of difference. Method of difference sums are going to be very easy. First, Sn such that Sn is equals to, see what is nth term? Fast. N into n plus 1 into n plus 2. What did I say? Once you get, because see now if you apply summation, sigma of this, sigma n cube you know, but sigma of 1 by n cube you don't know, na? For that we have to go with method of difference. So you have to express this numerator as the difference of, here what is the highest and least? N plus 2 is highest and n is least. N plus 2 minus n whole divided by n of n plus 1 into n plus 2. But we are not done. We have to balance it, friends. What do you mean by balance? Because when you write n plus 2 minus n, 2 is left over there. So this is what we say balancing. Now now what happens? This one 1 by 2 of n plus 2, that becomes 1 by of n into n plus 1 minus 1 by n plus 1 into n plus 2. Clear? Yes, clear. Now what happens? Sn, friends, Sn is equals to sigma of this an and n equals to 1 to n. I'll tell you the smallest approach, super approach which you have never seen in your entire life. That thing is, no need to simplify it, no need to simplify this, like put n1 again cancellation, nothing. See, just do understand. First of these two, just identify what is minimum and what is maximum. Very clear. N into n plus 1 is somehow the least input. N plus 1 into n plus 2 is somehow the larger input, right? This is smaller one. This is larger one. Now here, this is small input. This is large input. Put small one in smaller, large one in larger. Ho gaya. That gives the everything solution. 1 by 2 of small one value. That is 1 by 1 into 1 plus 1 minus large one is n itself. N plus 1 into n plus 2. My dear pretty friends, we are done with this entire one. Ho gaya. 1 by 2 minus of n plus 1 into n plus 2. Very simple approach, my dear friends. Very simple approach. I just tell you that first, no need to say, because objective, JEE, time, the less the time you take, the less you will be benefited. Do you understand? Here, no need to simplify anything. First, identify what is small part and larger part. Here, the small part has to be, the small part value kept in small value and larger input value has to be kept in larger. This is what our given thing. Ho gaya. Have you understood, my dear friends? We will be going with the next one. This is again directly here in this question they have given directly an. What is an? 1 by n into n plus 1 into n plus 2 into n plus 3. But what I said, friends, express the numerator as difference of the highest and least one. N of n plus 1 into n plus 2 into n plus 3. But in this, the 3 is getting extra. So just multiply and divided with 3 we did. Okay. Now you'll just understand the flavor of this. See, this becomes 1 by 3 of 1 by n into n plus 1 into n plus 2 minus 1 by n gets cancelled, n plus 1 into n plus 2 into n plus 3. Have you understood? Like, I'll just write here 1 by 3 of 1 by n plus 1 n plus 2 minus 1 by n plus 1 n plus 2 n plus 3. Now summation means like sigma an from n equals to 1 to 5. No, for that friends, least one should be kept to least value, highest one should kept highest value. That is 1 by 3 of this is least, this is highest. Very simple, no? So least 1 by 1 into 2 into 3 minus 1 by, put 5 here, 5 plus 1 6 into 5 plus 2 7 into 5 plus 3 8. That's it. Just simplify, you'll be getting the required thing. Such an easy problem, my dear friends. Such an easy and beautiful concept that we have in method of difference. One of the most important, friends, most important. See, again, first get the Sn. Getting Sn like an first. What is an? Numerator is sum of first n natural numbers and denominator is sum of the squares of natural numbers. Na? N square into n plus 1 whole square. I mean n plus 1 whole square whole divided by 4. 2 1s are 2 2s are. n gets cancelled, n plus 1 gets cancelled. So 2 by n into n plus 1. Clear? Is this clear? Now see, you have to express the numerator as 2 as like n plus 1 minus n whole divided by n of n plus 1. That becomes, friends, 2 of 1 by n minus 1 by n plus 1. हो गया? Yes, हो गया. Now we need Sn. Boss, Sn man, Sn. So that becomes Sn will be equals to, from n equals to 1 to, like Sn is equals to sigma an n equals to 1 to n. Now this becomes 2 of 1 by 1 minus 1 by n plus 1 only, because least is this, highest is this. Just this is our Sn. Now what this fellow is asking, 100 times Sn. 100 times Sn, that is 2 of 100 times 2 of 1 minus 1 by n plus 1 is going to be equals to n. Then they are asking now 200 times n plus 1 minus n by n plus 1 is equals to n. n gets cancelled. N plus 1 is equals to 200. Friends, n is equals to 199. Awesome problem that was asked in the year 2017. See, it just took 30 seconds. But this particular, if you are going to do with actual procedure, it takes minimum 3 minutes, minimum. So just don't waste time, friends. This is objective. We are going with the competitive exam strategy. One of the important method of difference. One particular question from this, friends. One from properties and one from the sigma notation. Clear? See, such an easiest procedure. Easiest. Friends, you have to get this till 11 terms. Homework I am going. Oh, I am giving you homework. Just we can go with directly get Sn, first an, express that an, the numerator of an as some difference of the highest and least, then you get Sn. Okay, this one also I am giving you as homework only, friends. This one also I am giving you as homework because we have solved many. Okay, thing is, approach is simple. Approach is going to be very simple. What is approach? Approach is get an, express the numerator of an as the difference of the highest and least and balance, then you get Sn. For Sn, for least you put least input, for highest you put highest input. That's it. I am giving you this also as homework, friends. This also as homework. Everything simple. Only thing here, identifying the nth term plays the major crucial role. Okay, this is directly they have given this one, the sum of this AP A1 and so on, A21 be an AP such that n equals to 4 by 9 if the sum of A6 into A16. Again everything same, friends, everything same. So here also sum of 10 terms, again nth term an, identifying an, express the an as difference of the highest and least of denominator, then solving it. Even this be, friends, even this also I am giving you as homework. This also I am giving you as homework. Again. This one also I am giving you as homework, friends. This one also I am giving you as homework. Guys, now another interesting question it is. In this, by using method of difference, see, this is neither in AP, nor in GP, nor in AGP, HP, nothing. Nor in sigma even. We can't even find A and 2. But we can do one particular thing that, see, if you observe the difference 4, the difference 7, the difference 10, the difference 13, this is found to be in AP. The difference is found, the difference of the consecutive terms is found to be in AP. The difference of the terms is found to be in AP. In that case, friends, we just take very simple approach is going to be very simple, friends. We just take Sn is equals to 3 plus 7 plus 14 plus 24 37 plus and so on Tn minus 1 plus Tn. That's it. Ho gaya. Now Sn, we just swap the term, like one term 3 plus 7 plus 14 plus 24 and so on. Here we write Tn minus 1, here I write Tn. Now I am going to subtract these two terms, friends. I am going to subtract Sn minus Sn. What will be that? 0. Get 3 here. Then 7 minus 3. See, 4. 14 minus 7. 24 minus 14. 10 and so on. I get Tn minus Tn minus 1 minus Tn I get. I just write that last Tn to this side. Therefore, Tn is equals to, my dear friends, I would like to tell you one thing. From here to here, this is an AP of n minus 1 terms. AP of n minus 1 terms. AP of n minus 1 terms. Then you can see, just look here, friends. AP of n minus 1 by 2 times 2a plus n minus 1 into d. 2a plus n minus 1 that is n minus 2 times d is 3. So that becomes 3 plus n minus 1 by 2 times 3n plus 6. Sorry, 8n minus 6. 3n plus 2. 3n plus 2. You can just take like LCM 2. So 1 by 2 of finally 2 into 3 6 plus n minus 1 into 3n, that becomes 3n square minus 3n plus n minus 1 into 2, that becomes 2n minus 2. Finally it becomes 1 by 2 of 3n square minus 3n plus minus n, 6 minus 2 plus 4. See, friends, we got it. Now this is what Tn. What is, now we got nth term. Once we get nth term, we can just Sn is equals to sigma Tn we get. Sigma Tn, that is nothing but 1 by 2 times 3 of sigma n square minus sigma n plus sigma times 4. We can do it now. I want you to complete the remaining, friends. I want you to complete the remaining by using our sigma rule. By using our sigma notations, you can sigma n square is sum of the squares of first and natural number. Sigma n, sum of first n natural number. Sigma 4 means 4 into sigma 1, that is n, 4n. Ho gaya. So by using that, you can just complete it. Here, this is a specific case called the difference of the consecutive terms is found to be in AP. Now we will be discussing one more sum where the difference of the consecutive terms will be in GP. Approach is going to be same. Difference. Okay. Hope you will complete the remaining part. Okay. Friends, very simple, very simple, very simple. Very simple. Coming to this sequence, as I said, the difference of the consecutive terms are found to be in GP. You see, 1 4 difference 3, 4 10 difference 6, 12, 3 6 12 with the first term 3 and common ratio 2. Okay. Now for this sequence, even same, Sn is equals to 1 plus 4 plus 7, sorry, 1 plus 4 plus 10 plus 22 and so on plus Tn, and same Sn, we are just swapping one term, 1 plus 4 plus 10 and so on plus Tn minus 1 plus Tn. Now difference of these two, friends, the difference of these two, Sn minus Sn is 0, 1 here, 4 minus 1 3 plus 6 plus 22 12 and so on, we get Tn minus of Tn minus 1 minus whole Tn. Get the Tn to the left hand side, get the Tn to the left hand side, then you get Tn is equals to 1 plus, friends, this is a GP geometric progression of n minus 1 terms again, of n minus 1 terms, that is a into, what is first term, 3 into r to the power, what is r, 2 to the power n minus 1, n minus 1 minus 1, n minus 2. Ho gaya, friends, ho gaya. So this is what Tn is equals to 1 plus 3 times 2 to the power n minus 2. Now applying to get Sn, we just take sigma n, sigma Tn, we just take sigma Tn. Now sigma Tn will be sigma 1 plus 3 times of sigma 2 to the power n minus 2. Sigma 1 is anyhow n plus 3 times of put n 1. In that way, you will be getting a sequence in GP. You will be getting a sequence in GP. N equals to 1, that is 2 power minus 1 plus 2 power 2 minus 2 0 plus 2 power 1 plus 2 power 3 and so on, 2 to the power n minus 2 you get. So this is what, my dear friends, very simple na. GP, sum of finite GP, you know, a into r to the power n minus 1 by r minus 1, n we know. So here the difference, whenever the difference of the consecutive terms is found to be in GP, this is what the approach. AP, same approach is same till you get nth term. After getting nth term, even this particular things also called as some special sequences, we say. This particular, by using Sn sigma, we get everything, friends, everything. So my dear best friends, like this is what we have seen. Like if the different series are in AP, then we take an square is Tn is equals to an square plus bn plus c, where a, b, c are being constants. That is what here we have seen now. This is what here we can, when the difference is found to be in AP, directly we can take Tn is equals to some an square plus bn plus c. Tn is equals to, we can take an square plus bn plus c. We can put n equals to 1, we get 8, some 3, put n equals to 2, we get 3 plus 7, 10, put n equals to 3, in that way we get actually. But I prefer, like whether you solving for ABC, you get it, no issues in that. I always prefer to go in this particular procedure. But if you wish to remember that, it's enough. Okay, now again, see, if the difference is found to be in AP, then you can take 10th term will be always of the form an square plus bn plus c, quadratic. If the difference of difference, sometimes they'll be giving you a sequence, like they have given a sequence now. Once we do difference, again for that consecutive terms, if you do again difference, that term, that sequence is found to be in AP. See friends, like you just understand, Tn in generally nth term of an AP will be of the form an plus b. See, difference is found to be in AP, then we got quadratic. Difference is found to be in AP, difference of difference, again cubic. So this is how the pattern is going to be. Clear? But never ask such things again, but just be prepared till here. Just do understand this too. Okay? And case 2 for GP1, we have in general Tn is equals to a into r to the power n minus 1. Now, if the difference is found to be in GP, we get Tn, that's what we have seen now. T into r to the power n. See? Now, if the difference is found to be in AP, if the difference is, we get a into r to the power n plus b. If the difference of difference will be observing in this particular form. Now, my dear friends, I always, after getting all these, we just apply sigma to our nth term, then we get summation. My dear friends, this is this sequence and series lecture. In this sequence and series lecture, we have covered each and every minute thing which was useful for JEE. Every problem we have covered in PYQ and every concept we have covered. Even we have covered more than what we require to. So my dear friends, I request everyone to go through the complete lecture, take down the complete notes and make sure all the problems which are assigned to you for homework, you are doing it on your own. And if you are facing any problem with any particular problem, just put the question number and everything in the chat box, in the comment box, then I'll be replying to it. Is that clear, my dear friends? So this, we are done with this particular sequence and series lecture. In the next the next lecture is going to be quadratic equations, will be updated soon. My dear friends, till then, make sure that you are going through the entire and all the assigned problems has to be completed by you. Then only you will be making yourself the best in JEE Mathematics. But before leaving, please make sure you like, you subscribe, and you share it with your friends. Okay, that's it for today, friends. Take care, everyone. Bye. See you in the next session. All the best.